With the help of the Hubble Space Telescope, which probed space in the second half of the 20th century, astronomers attempted a daunting challenge: to draw a map of the cosmos, locate our solar system and the Milky Way in the universe, and predict their direction. Although Albert Einstein presented his theory of general relativity in 1917, suggesting that the universe was static and bounded, he was forced to admit his error 10 years later. In 1929, the Hubble-Lemaître law, predicted 2 years earlier by Lemaître, demonstrated that our universe is in continuous expansion, and what's more, at an insane speed. Like all galaxies, our Milky Way is caught up in a cosmic flux, triggered by the Big Bang. Since then, the early universe has expanded in all directions and at an ever-increasing speed. As a result, the distance between all galactic structures is growing ever greater. Like splashes, we imagine that galaxies move at similar speeds on either side of their starting point. But this is not the case. The force of gravity drives many objects to gather into clusters and superclusters. It precipitates the local cluster, the group of galaxies to which we belong, at over 2 million kilometers per hour, or 1.2 million kilometers per hour, in the direction of the Virgo cluster through the immense Laniakea group. In the 1970s, observation of their motion revealed that the expansion of the universe was not uniform. A deviation, reflected in variations in the offsets between certain galaxies, between minus 700 kilometers per second and plus 700 kilometers per second, or minus 430 miles per second and plus 430 miles per second, highlighted an anomaly. The local group, among others, is deviating from the general expansion of the universe at a speed of 366 kilometers per second, or 227 miles per second, in the direction of the Centaur. In the deep cosmos, somewhere in the fuzziest zone of space, masked by our galactic plane, an invisible magnet seems to be drawing us into its meanderings. But this massive gravitational irregularity doesn't just affect the Milky Way. It attracts thousands of other nearby galaxies. This anomaly has been dubbed the Great Attractor. Its location, determined in 1986, places it between 150 and 250 million light-years from the Milky Way, in the direction of the Southern Triangle and Ruler constellations. With its colossal force, attributed to a mass estimated at several tens of millions of billions of solar masses, this anomaly appears to operate from the gravitational center of the Laniakea supercluster. Above all, it has the ability to attract galaxies within a radius of around 300 million light-years. Despite technical innovations in astronomical observation, this superstructure remains an enigma. For some, it could be a confluence of dark energy, attracting to itself any galaxy close enough. For others, the anomaly could be the result of overdensity, a zone of very dense mass generating an intense gravitational attraction. The beginnings of an explanation emerged in the early 1980s, thanks to an international collaborative study. The largest concentration of large-scale matter in the near universe was detected in this hidden region of the cosmos. Known as the Shapley supercluster, this structure of 44 clusters totaling 8,000 galaxies, spans more than 120 million light-years, and weighs approximately 10 million billion suns. But the discovery of this megastructure is not enough to explain the anomaly. Although it has a staggering mass, it is only half of that needed to draw us to it. What's more, it seems to be located behind the Great Attractor, which still remains a mystery. But it's not just cosmic objects that are subject to the sometimes puzzling temperament of the universe. In the early 70s, 2 space probes were launched, with the mission of making an initial reconnaissance of the planets of the outer solar system. In 1972, Pioneer 10 was the very first spacecraft to break free of the asteroid belt and fly past the planet Jupiter before reaching the liberation velocity required to leave the solar system, followed by Pioneer 11. The second probe took the opposite direction the following year, heading for Saturn after a close study of the Jupiter red spot. Unexpectedly, as the probes moved away from the Sun, an invisible force seemed to hold them back in their respective launches. The appropriate model, taking into account all the effects that could influence the speed of this type of craft in interstellar space, turned out to be wrong. As early as the 1980s, astrophysicists noticed that their speeds were steadily decreasing, despite their opposing trajectories. Although the probes had fulfilled their mission, their observation was continued over time, using the Doppler effect. For a long time, this phenomenon was downplayed as inherent to the probes themselves. Fuel leaks could have affected the probe's orbits. Or has the impact of radiant heat from the plutonium used, or of light on the solar sails, been underestimated? For some scientists, Newton's theories and Einstein's relativity are being called into question. This suggests that gravity could imperceptibly gain strength over enormous distances. But if so, why don't the planets themselves seem to be affected? In any case, the behavior of the Pioneer 10 and 11 probes continues to intrigue scientists. Delayed by 500,000 kilometers, or 310,000 miles in recent years, these 2 spacecraft have helped detect this anomaly, which, if not elucidated, could well upset the foundations of current physics. But before we enter our hibernation chambers and drift off into a deep sleep, let's take a closer look at one of Saturn's moons. Behold Titan, the only known cosmic object to exhibit a stable liquid surface mass. This feature, though extraordinary, is not the only one this satellite possesses. Even more disconcerting, near its north pole, in Titan's second largest sea, called Ligeia Mare, a luminous object seems to be playing hide-and-seek. Sometimes visible, sometimes nowhere to be seen, unlike its direct vicinity, this zone was explored as early as 2004 by NASA's Cassini probe. But it was in July 2013 that it was first spotted in images from the same probe, before disappearing again a few days later. The area, estimated at around 260 square kilometers, or 160 square miles, finally reappeared in images dating from August 2014. To everyone's surprise, its appearance was different from that observed 2 years earlier. Is it an object floating on the surface of the sea, which for some unknown reason remains static? Or is it simply a change in the landscape, suggesting the presence of dynamic geological mechanisms in Titan's atmosphere? Researchers have put forward several hypotheses about the nature of this strange island. It could be caused by waves linked to an atmospheric phenomenon, or it could be composed of gas bubbles emanating from the depths of this liquid expanse. The appearance could also be explained by the formation of methane ice, or even an increased concentration of suspended particles, such as silt floating between two levels of water. But for some scientists, these extraordinary changes on the moon's surface are akin to the seasonal changes on Earth. Indeed, they have noticed that this mysterious island has always revealed itself at the beginning of summer in the northern hemisphere. It could, therefore, be linked to seasonal events, but over a longer period than our 4 seasons. As you can see, it's not only nature on Earth that has some surprises in store for us. This discovery, like a waking dream, brings us back to our collective phantasm, finding another habitable planet. Our sidereal journey now takes us to a strangely dark area of space. I invite you to step out of your chamber and let yourself be absorbed by this strange universe, virtually devoid of any visible matter. Faced with this enveloping, even deafening blackness, the surprise is total. Here you are in the middle of nothing, or almost nothing. But don't panic. Don't let this frightening environment overwhelm you. We're not sinking into an endless cosmic hole. Although space seems to be dotted all over with objects of varying luminosity, there are a few vast places where, strangely enough, emptiness dominates. We're currently right in the middle of one of them. It's the local hole, also known as the Keenan-Barger-Cowie Void, or KBC Void. This structure, or local subdensity, is no more and no less than a vast expanse, where matter has a density around 20% lower than the average of the observable universe. Studied in 2013 by 3 astronomers, the local hole closely resembles a sphere, around 2 billion light-years in diameter. And I'm going to surprise you. This cosmic void isn't as empty as it looks. I could even say that your cosmic address depends on it. In fact, it contains most of the Laniakea supercluster, including the local group, and consequently, the Milky Way. Our sun is only a few 100 million light-years from the center of the local hole. Here's another piece of information that's sure to baffle you. Cosmic voids like this one exist in dozens of other, less exceptional dimensions. The only cosmic void larger than the local hole is nearly 3 billion light-years across. Thus, when observed on a very large scale, the universe resembles a cheese of holes, with zones rich in matter and others largely empty. Our galaxy and its wider neighborhood are therefore evolving in an immense empty bubble. According to the cosmological principle, the distribution of matter throughout the universe is fairly homogeneous, even over vast observed areas. While this can be confirmed on scales of around 250 million light-years, when we look at even larger regions, these cosmic holes appear. But what's even more interesting is that these voids could explain the discrepancy in Hubble constant measurements. Indeed, depending on the observational methods used, the expansion velocity of the universe presents contradictory values, known as the Hubble tension. The velocities of thousands of galaxies just located and counted were found to be 10% higher than those predicted by the lambda cold dark matter model. Makes you wonder whether the standard lambda cosmology model is really reliable, doesn't it? Could it be that unknown forces or manifestations are influencing our universe? This could explain why the model's predictions turned out to be wrong after these observations. The KBC vacuum is therefore a density anomaly, which, in addition to challenging our current understanding of the dynamics of our universe, could provide the beginnings of an explanation for some major inconsistencies. Scientists at the University of St. Andrews recently put forward a hypothesis. The velocity fluxes of galaxies, i.e., the speed at which they move as a group across the universe, would naturally be higher in and near this cosmic void, rather than in constant acceleration. They suggest that galaxies located within, or relatively close to this void, would exhibit higher velocities due to differences in matter density and, consequently, discordant gravitational forces. In short, local variations in the expansion rate of the universe would be related to Newton's laws of gravity, which are supposed to apply uniformly throughout the universe. Thus, according to their theory of modified Newtonian dynamics, MOND, regions similar to this void would experience a weaker gravitational force, resulting in greater velocity. If this explanation proves relevant, in addition to challenging the foundations of gravity theory, it could mark the beginning of a new age in cosmological research. Your hibernation chamber, programmed to bring you gently back to a state of wakefulness, has just opened. Your eyes are immediately drawn outwards by countless luminous galactic filaments. Here we are, close to the largest superstructure in the universe known to date. You're looking at the Great Wall of Hercules' Crown Borealis, also known as the Great Wall of Hercules' Corona Borealis. This gigantic group of galaxies lies around 10 million light-years from our Sun, in the constellation of Hercules and Corona Borealis, as its name suggests. Its discovery, which dates back only to November 2013, can be explained in part by its remoteness. Scientists spotted it by mapping gamma-ray bursts, the dazzling explosions of the most powerful stars in the cosmos, far away and massive. But they had to be patient. Indeed, these explosions, which release more energy in less than 1/10 of a second than our Sun will produce in its entire existence, are extremely rare. In an ordinary galaxy, explosions of this type occur only exceptionally, at the rate of one every few million years. The stars that cause these cataclysms are very massive, requiring large quantities of matter for their formation. If these explosions can be used to pinpoint a galaxy or a large body of matter, they need to be the subject of lengthy study, involving the recording of colossal quantities of data. This is what astronomers set out to do, mapping these luminous phenomena from 1997 to 2012. To do this, they used the Fermi and Swift robotic satellites. The latter were designed to detect gamma-ray bursts by measuring their redshifts. The study of the data collected paid off. The map drawn up over 15 years of observation revealed 14 gamma-ray bursts with redshifts. What's more, these similar explosions were very close together. For scientists, there can be no doubt. This far-flung region of space is home to a very large group of galaxies and large quantities of matter bound together by gravity. According to their estimates, this structure, home to billions of galaxies, seems to measure 10 by 7.2 billion light-years. However, while it covers just over 10% of the diameter of the observable universe, it is only 900 million light-years thick. Until now, the largest observable structure in the universe was represented by the group of large quasars, measuring 4 billion light-years. To give you a better idea of these unusual dimensions, remember, our galaxy, the Milky Way, measures just 100,000 light-years in diameter and is only 2.5 million light-years away from its nearest neighbor, the Andromeda Galaxy. But how does this discovery fit in with the list of space anomalies? To cut a long story short, the Great Wall of Hercules' Corona Borealis doesn't fit in with the principle of cosmology, Albert Einstein's famous theory mentioned earlier. According to this principle, the entire universe is isotropic. Cosmology therefore stipulates that the universe is the same in all directions, spatially homogeneous, and similar at every point on a scale of several hundred million light-years. Thus, scientists who assume that matter has been evenly distributed since the creation of the universe predicted that no structure could be larger than 1.2 billion light-years. However, the Great Wall of Hercules' Corona Borealis is 8 times larger than this supposed limit, calling this cosmological principle into question. What's more, this imposing structure contradicts theories on the evolution of our universe. This glittering wall you can admire is some 10 billion light-years away from our Earth. This means that terrestrial observers have seen this structure as it existed 10 billion years ago. The famous Big Bang at the origin of our universe occurred 13.8 billion years ago. This difference is far too short. How could such a gigantic structure have formed in just 3.8 billion years? The existence of such a structure remains a mystery to astrophysicists. With their current understanding, they are unable to explain how it could have formed in such a short space of time. The Great Wall of Hercules' Corona Borealis could well compromise the veracity of the Big Bang theory. As their discoveries continue, astrophysicists are constantly adding to their list of enigmas to be solved. One of them is to explain the presence of rings around objects that shouldn't have them. As a reminder, only Saturn, Jupiter, Uranus, and Neptune, the giant planets, were equipped with these attributes in our solar system until this unexpected discovery. Introducing Chariklo, an asteroid discovered in 1997 that orbits more than 2 billion kilometers, or 1.2 billion miles beyond Saturn's orbit, deep in our solar system. While it is the largest member of the Centaur asteroid class, with a diameter of 302 kilometers, or 188 miles, it has been favored by many observers since 2013 for its astonishing peculiarity. This asteroid, around 50 times smaller than the Earth, has two rings. See how dense and narrow they are. Estimated at just 5 kilometers or 3 miles wide, they orbit at an estimated distance of 400 kilometers or 250 miles from the primary object. It is the smallest celestial body encircled by rings discovered to date. But it's not the only one. In 2017, a second such discovery was announced, this time concerning a small planet in the Kuiper Belt. Look at this piece of rock showing off its rugby ball appearance. It's Haumea, a dwarf planet averaging 6.5 billion kilometers, or 4 billion miles from our Sun. While trying to determine the size of this object, detected in 2004, astronomers discovered its particularly dense equatorial dust ring. No fewer than 12 telescopes pointed their lenses in Haumea's direction as it passed in front of a star, the ultimate condition for determining its dimensions. But to the great surprise of the researchers, a rapid extinction preceded the passage of this dwarf planet in front of the luminous star. They were able to establish that this dwarf planet, with a diameter approaching 2,000 kilometers, or 1,300 miles, is surrounded by a fairly narrow ring, around 70 kilometers, or 44 miles, but particularly dense, which orbits it at a distance of around 1,000 kilometers, or 620 miles. No explanation has yet been found for the origin of this ring. Is it an ephemeral phenomenon, or is it long-lasting? What is certain is that this anomaly could indicate that rings surrounding dwarf planets may not be as rare as scientists previously thought. In fact, an even more sensational discovery was made in the following years. This time, a ring was detected near an even more distant trans-Neptunian object. Meet Quaoar, a dwarf planet whose ring is not only unpredictable but also curiously located, hence its late discovery. In fact, Quaoar was discovered in 2002, while its ring was only recently detected and revealed to the public in February 2023. Quaoar was discovered by a team of American astronomers during Caltech's large-scale sky survey. As they surveyed the Kuiper Belt for the brightest objects, their attention was caught by a dark object of apparent magnitude 18.6. It was moving slowly in relation to its background, a cloud of distant stars. Scientists call this phenomenon occultation. Its diameter, quickly estimated using data from the Hubble Space Telescope, is around 1,110 kilometers, or 690 miles, giving it the status of a dwarf planet. It is also one of the largest objects in the Kuiper Belt. In addition to its size, this dwarf planet has a satellite. It's a moon, about 170 kilometers or 105 miles, called Weywot. But what's even more incredible is that this small planet, which orbits our Sun at a distance equivalent to 43 times that separating the Earth from the Sun, is surrounded by an extraordinarily distant ring. With a radius of 4,100 kilometers or 2,600 miles, it lies well beyond the Roche limit, defying previous models for the formation of such a structure. No other ring has ever been detected so far from its planet. This one is more than 7 times its radius, marking the boundary of the Roche limit. According to this model, a ring could not exist beyond 2 to 3 times the radius of the central body. This discovery is an anomaly for scientists, running counter to the above-mentioned model, whose origin lies with astronomer Edouard Roche. The rings are not supposed to exist in such a remote perimeter. The particles of matter present in this zone should have agglomerated with each other, since they are not subject to the tidal effects produced by the main body, which are greater than the gravitational cohesion forces taking place between them. And yet, despite being outside the Roche boundary, these numerous pieces of debris don't seem to be undergoing this long agglomeration process at all. So how does such a ring manage to endure over time? Here's one more mystery for astrophysicists. The icy temperature of the ring's debris could provide the beginnings of an explanation. Some scientists believe that the ice particles undergo so-called elastic collisions, preventing them from sticking together. So what you have before you is an exceptional, unusual, even inexplicable ring, at least for the time being. Admittedly, it doesn't have the splendor or grandeur of Saturn's rings. Nevertheless, its position in relation to Quaoar makes it unique, especially as it hides the secret of its very existence for the time being. But how about a little rest? After observing these anomalies, each more disconcerting than the last, a good night's sleep will enable us to tackle the next stage of our exploration with slightly clearer skies. The next time we wake up, a new surprise awaits you. Look at this exceptional star. This is Tabby's star, one of the most mysterious and exciting stars in the Milky Way, just 1,470 light-years from our Sun. Tabby's star, which cohabits in the constellation Cygnus alongside numerous other luminous objects, stands out from its companions in a singular way. Although first detected in 1890, Tabby's star has been the subject of particularly close study in recent years. The reason for this is its unusual light fluctuations. While the Hubble Space Telescope recorded variations in the brightness of over 100,000 stars in the Cygnus and Lyra constellations, data collected between 2009 and 2013 led astronomers to take a closer look at this star. For scientists searching for exoplanets, the brightness fluctuations recorded are unmistakable. There is probably a large mass or many small masses in close formation in its vicinity. This is why there is so much interest in this star, potentially accompanied by an exoplanet. Observations show that the star displays an atypical light curve for a number of reasons. It shows both periods of deep decline and long-term changes. On several occasions, its brightness has declined to as much as 22% of normal. What's more, a study of the archives revealed that this seems to have been happening repeatedly over a number of years. Now, if a planet the size of Jupiter were to occult this star, not only would it lose no more than 1% of its brightness, but more importantly, these changes in brightness would be cyclical. Except that, in this case, the fluctuations are totally random. Scientists then speculated that it could be an occultation linked to a random phenomenon occurring between Tabby's star and the observation zone. But this hypothesis doesn't hold water, especially as periods of significant brightening have also been recorded. I'm not going to hide the fact that the idea of an extraterrestrial megastructure has occurred to a few followers of this dogma. A Dyson sphere set up by an alien civilization would then be able to appropriate some of this light to meet its energy needs. But this idea was dismissed as preposterous by most. In fact, as you can see, there's no sign of any unknown technology being installed. But then what could be blocking the light from this star during the darkening phases we've noticed? The most simplistic hypothesis suggests that irregular dust clouds or orbiting debris could explain this phenomenon. However, the researchers noted that the infrared wavelengths of light pass through the gradation more easily than the ultraviolet bands. For them, this observation rules out the possibility of a solid object. Could it be the debris of an exoplanet or an exolune torn apart by the star? Or could it be several groups of comets sailing alongside it, like swarms of bees? Or are they inherent fluctuations of the star itself, like the famous Betelgeuse? But in that case, why these versatile variabilities? Could it be that the star is undergoing a natural process that means it has reached a critical stage of phase transition? Whatever the case, in order to unravel this mystery, scientists need to be sure of one thing. If it's an interference due to the superposition of an occulting material, they'll have to confirm its circumstellar nature and then its nature. If this is not the case, new alternative models for starlight could be developed. And what about you? What's your opinion on this anomaly? Just a stone's throw from this star with its strange behavior, we broach the subject of extraterrestrial entities. This must remind you of an unusual phenomenon you've probably heard of, still considered an anomaly for want of a plausible explanation. On October 19, 2017, a mysterious object was spotted as it passed through our solar system, baffling astrophysicists for many reasons, with some even considering the possibility of extraterrestrial technology coming to visit us. This fabulous object was detected by Hawaii's Pan-STARRS telescope and christened Oumuamua, scout or messenger in the Hawaiian language. Its hyperbolic trajectory and unusually high speed led to the conclusion that it came from another star system. Coming from who knows where, this bolide was the first interstellar object to visit us so closely, before continuing its long journey to an unknown destination. With its cigar-shaped ship-like appearance, it brought to mind certain cinematic images, often ominous. As you can imagine, this interastral intruder did not go unnoticed for a number of reasons. First of all, its dimensions. Measuring in length between 200 and 400 meters, or 600 and 1,300 feet, with a width 10 times less than its length. What's more, the object's brightness and variations in luminosity could lead observers to believe that it was a metallic object rotating on itself. Once again, science fiction films are full of spaceships based on similar movements. Its appearance wasn't the only thing that puzzled scientists. Its attitude proved just as disconcerting. While from a rational point of view, it resembled an asteroid or comet, it displayed neither the sparkling tail nor the halo usually attributed to the latter. Even more disconcerting was the way it crossed our solar system. When it was detected at a distance of around 30 million kilometers or 19 million miles from the Earth, its speed was estimated at 50 kilometers per second or 31 miles per second. Then, as it drew closer to our Sun, it accelerated progressively until it reached 87 kilometers per second or 54 miles per second. But perhaps the strangest thing about it was its rocket-like behavior. Indeed, after orbiting the Sun, it experienced an extraordinary acceleration as it changed its trajectory. At that very moment, it was traveling at a speed of over 300,000 kilometers per hour, or 185,000 miles per hour, heading for the constellation of Pegasus, before finally exiting our solar system. Scientists theorize that such a brief visit by such a cosmic object could have been the result of a spacecraft. Could it have been a simple asteroid, an atypical comet, a hydrogen iceberg, or the debris of an exoplanet? Naturally, researchers tried to unravel this mystery by mining the data collected, specifically those concerning this fabulous acceleration coupled with an improbable change in its trajectory. Neither a gravitational kick from the Sun nor an outgassing phenomenon seem to explain this supernatural behavior, contrary to the laws of physics. What's more, no unusual radio emissions were detected during the same period. Since 2019, a study by the Astronomy Department of the University of Maryland has settled one point. The object did not originate from an alien entity, and its natural origins were justified. According to a study published in Nature magazine in March 2023, it is a water-rich object, similar to a comet that has undergone significant weathering. It reports that Oumuamua, like comets, is essentially composed of water and rock. The object would have been propelled far from its star's gravitational grip before drifting off into interstellar space. During its long cosmic wanderings, it would have been bombarded by cosmic rays, particularly energetic particles that can penetrate dozens of meters beneath the ice. According to one model, more than a quarter of the water molecules present on Oumuamua were transformed into molecular hydrogen, which was then trapped in countless small pockets of ice. When the object got close enough to our Sun, at a distance of tens of millions of kilometers or miles, the hydrogen ice would have undergone a sudden change of state, transforming into gas. By escaping on its own, the hydrogen gas would then have propelled Oumuamua, causing the abrupt change in direction observed. This hypothesis, which holds true for many scientists, helps explain why no halo or streak was detected by telescopes in 2017. The exact nature of Oumuamua cannot be certified to this day, leading, as you've seen, to major discrepancies in the sphere of astrophysicists. This object has definitely left our solar system, taking with it a mystery that will never be solved. However, future observations by the Vera Rubin telescope in Chile, due to begin in 2025, could well change all that. Designed to detect new comets, both inside and outside the solar system, it should be able to collect relevant data on them. If, like Oumuamua, the smallest comets show signs of releasing trapped hydrogen and do not display a characteristic tail, then the existence of this new type of comet could be confirmed. How about that? Our onboard computer reports that it has recorded a radio signal that seems to be repeating itself on a regular basis. Let's take a closer look. The transmission comes from the constellation of Sobieski's Shield, east of the tail of the serpent. The ground team confirms that they too have detected this unusual signal. They tell us they've observed the signal lasting from 30 seconds to 5 minutes, repeating itself strangely, slowly every 21 minutes. Our cross-reference data indicates that we are indeed interested in the same phenomenon. What could be behind such a radio source? Could it be an extraterrestrial radio signal? Of course it could. But let's not panic. This signal mustn't be perceived as a threat. Let me explain. This intriguing radio signal was first detected in 2022 by Australia's Murchison Wide-Field Array Radio Telescope, before being observed and then confirmed by numerous other facilities worldwide. In a study published in July 2023 in the journal Nature, researchers from Australia's Curtin University report their findings. Although they are not yet in a position to catalog the object perfectly, they do offer some explanations. It turns out that this extraterrestrial signal is emitted by an astral object named GPM J1839-10. Yes, you heard me right. It's coming from a star, not from an entity potentially in search of traces of distant life. However, this stellar object, which behaves like a pulsar or magnetar and is located 15,000 light-years from Earth, has left scientists stunned. Radio signals from such stars, sweeping across our Earth on a regular basis, are nothing out of the ordinary, you may say. And yet, there's nothing coherent about this one. As you probably know, magnetars, or dying stars, produce energy at regular intervals. These neutron stars, with their extremely powerful magnetic fields, are particularly dense, rapidly rotating objects. The flashes they produce last only a few milliseconds, rarely more than a second or two, and are repeated at a steady rate of no more than a handful of minutes. In this particular case, let me remind you that the powerful radio beams detected last up to 5 minutes and are repeated only every 21 minutes, which is inexplicably slow for such an object. Such periodicity has never been observed before. Could it be that scientists have spotted an exotic object never before discovered? Subsequent study of the telescopic archives revealed another fact about these enigmatic radio wave emissions. The scientists, totally baffled, asserted that these have been recurring since at least 1988. This means that the star has been transmitting in this way for over 35 years. In January 2022, the discovery of a similar object, J1627-5235, was also announced. This transient object also emitted strong radio emissions lasting 60 seconds and recurring every 18 minutes. However, according to recent monitoring and archive data, its radioactivity was short-lived compared with that of its counterpart. It lasted just 3 months out of 8 years of observation. If it is indeed a magnetar, such a discovery calls into question current knowledge of this class of neutron stars. As they age, their magnetic fields gradually weaken, inevitably slowing down their rotational speed. Then, when they reach the death line, the threshold at which they can no longer produce high-energy emissions, they fall silent forever. In our case, however, this limit has been well exceeded. Nevertheless, this beam of radio waves continues to rotate, like a tireless cosmic beacon. Scientists believe that it could be an extraordinarily slow magnetar, or even a white dwarf radio pulsar, but one thing is certain. Even if one of these two hypotheses proves to be correct, both involve numerous parameters and uncertainties that remain to be elucidated. Let's add this new anomaly to the many other cosmic mysteries and continue our journey. Let's make sure everything's okay, shall we? What are you staring at? What are you saying? A curious circular mist? Yes, it is. Our radio wave measuring equipment is categorical. Straight ahead of us stands a strange ring of cosmic smoke. Its ghostly appearance partially obscures the stars in the background. If we were observing it through a telescope, I'd certainly advise you to clean your lens. A priori, this enormous structure, large enough to contain entire galaxies, is only detected in the radio range. None of our other measuring devices seem to perceive it. This reminds me of a recent discovery. I think we're looking at an odd radio circle, or ORC for the more erudite. The first such object was detected in 2019 by astronomer Anna Kapinska. When she presented this image to Ray Norris, a science professor at the University of Sydney in Australia, she named it WTF, for what the fuck, which shows just how disarming, even frightening, this discovery proved to be for her. Before publishing the result of this astounding discovery, the astronomers preferred to wait several months. In particular, they wanted to be sure that the signal detected was not an astronomical mirage that could be attributed to the measuring equipment. Further data collected by an Indian radio telescope confirmed this unusual discovery. No plausible explanation for this strange radio circle, which resembled a ball of smoke, could be found. For some, this puzzling phenomenon could be linked to a wormhole. For others, it could be the result of an explosion in a deep space galaxy, or a collision between a powerful neutron star and a black hole. Just a few days after this exceptional discovery, a second strange radio circle was detected, proving that this was not a unique case. To date, only 11 strange radio circles have been spotted, but researchers believe that thousands more could well be discovered in the not-too-distant future. However, observing them is proving very difficult. These structures, although colossal, with a diameter of several 100,000 light-years, 10 times wider than our own Milky Way, are billions of light-years away. What's more, as mentioned earlier, they emit light only at radio wavelengths. Since then, Ray Norris and his team have taken a very close look at the very first strange radio circle discovered. To do so, they used the Meerkat antenna array at the South African Radio Astronomy Observatory. With 64 domes, each measuring 13.5 meters, or 45 feet in diameter, this is the world's most sensitive and precise radio wave equipment. The anatomy of this foggy ball has been revealed to scientists, revealing itself to be far more complex than presumed. The spherical structure is made up of several intersecting arcs. Above all, at the very heart of this system, a tiny dot has been spotted. It is possible that this dot, which also appears in images taken at other wavelengths, is an immense elliptical galaxy. For the researchers, there's almost no doubt. These two elements, the strange radio circle and the galaxy, are linked, the latter probably being at the origin of this anomaly. But how? The origin of this huge ring of radio waves remains a mystery, and various hypotheses are being discussed. The first suggests that the galaxy in question experienced a period of intense star formation. Their successive cataclysmic births and deaths would have violently pushed back the surrounding gas and particles, triggering an expanding shock wave. The second theory suggests a collision between two supermassive black holes located in the interior of this galaxy. This strange radio circle would then be a shell formed by outgoing galactic winds. This scenario, if it exists, has never yet been observed, although it is one that greatly arouses the curiosity of astrophysicists. Finally, others believe that we are simply looking at the barrel of a powerful jet, emerging from the active nucleus of this same galaxy. As the exact origin of these strange radio circles remains unresolved, I suggest we divert our trajectory so as not to travel too close to this gigantic structure. After all, the consequences it could have on our interstellar journey are unknown. Now that we've reached cruising speed, I suggest you take in the scenery. Look out into the distance. The stars are covering the cosmos in all their glory. You have the privilege of admiring an area of space that is home to a huge cluster of galaxies. Meet the Giant Arch. With its crescent shape, this grouping extends over 3.3 billion light-years. Distant from our galaxy by 9.2 billion light-years, it is one of the largest structures ever observed. Made up of galactic clusters, galaxies, and abundant amounts of gas and dust, it stretches across nearly 1/15 of the observable universe. To give you an idea of its scale, the Giant Arc, if visible to the naked eye from Earth, would represent, despite its remoteness, almost 20 times the width of the full moon. If it was only discovered in 2021, it's because such a structure, according to established models of the cosmos, isn't supposed to exist. According to the Standard Model, the current theoretical limit predicts that the size of a structure should not exceed 1.2 billion light-years. And yet, the 45 to 50 galaxies in the Giant Arc are bound together by gravitational forces, as in any galaxy group. It was therefore detected by chance, while a scientist named Lopez was assembling maps of objects in the night sky using the light from 120,000 quasars. She then realized that the specific signature of certain halos from several dozen galaxies was similar. Mapped in 3 dimensions, the structure discovered turned out to have this atypical arc shape. To assess the probability of galaxies forming such a vast alignment in space, the scientists used 3 different statistical methods. All of them showed that the hypothesis put forward was not all that fanciful. The discovery of this gigantic galactic arc calls many things into question, but it's not the only one to baffle astrophysicists. The Great Sloan Wall and the giant GRB ring, with respective diameters estimated at 1.38 and 5.6 billion light-years, are 2 other unlikely groupings already observed. The Great Wall of Hercules Corona Borealis, visited a little earlier, remains the largest known structure in the universe, totaling 10 billion light-years, whose existence also continues to raise many questions. With our eyes immersed in this ultra-large structure, we've completely forgotten about our surroundings. Let's take a step back and look at the giant arc's surroundings. What do you notice? Isn't there another imposing structure looming in front of you? In this same region of the universe, close to the constellation Bouvier, another grouping of galaxies forms a gigantic ring of light. But unlike other circular structures, this one resembles a helix, taking the form of a complex spiral. While this unusual appearance is striking for any seasoned observer, its dimensions are once again beyond comprehension. This colossal structure, with a diameter of around 1.3 billion light-years, has only just been detected. The announcement of its fortuitous discovery was revealed, also by Alexia Lopez, at the 243 meeting of the American Astronomical Society, which has just taken place at the start of 2024. The Great Ring, as this new structure has been christened, is almost similar in size to the giant arch discovered 2 years earlier. If this structure could be opened up into a curved shape, its circumference would equal the length of the giant arch. To get a better idea of the ring's gigantic size, consider that if it were visible to the naked eye from Earth, it would cover the night sky like 15 full moons in a row. In addition to their extraordinary dimensions, i.e. in excess of 1.2 billion light-years, the theoretical size limit, these 2 giant structures also raise another question for cosmologists. Given that the giant arch and the Great Ring are located in the same region of the cosmos and at the same distance from Earth, is it possible that they are connected to each other? In short, that they are part of the same, even more extraordinary cosmological system? These latest discoveries add up to new evidence that compromises our current understanding of the universe. Once again, the cosmological principle that matter is homogeneously distributed throughout the universe may well be proven wrong. Shouldn't scientists start examining this possibility? Shouldn't they shatter what they once believed to be irrefutable, i.e. all manner of theories and rules governing the laws of the universe? Crazy as it may sound, many scientists say they're ready to consider it. But before they can do so, they'll need even more convincing arguments. For this, new research in the direction of as yet unexplored objects or structures, which are consequently very difficult to detect, will have to provide new tangible proof. However, another argument is also being debated by astrophysicists. Some so-called impossible or early galaxies tend to confirm that the cosmological principle may well be obsolete. Thanks to new observations by the James Webb Space Telescope, scientists have discovered almost half a dozen galaxies that appeared just after the Big Bang, displaying unexpected characteristics. To everyone's surprise, these galaxies are so massive that they could call into question their very origin. Joel Leha, professor of astronomy at Penn State, announced that instead of tiny galaxies, they had detected disconcertingly massive ones. These turned out to be as mature as the Milky Way in a region of space then considered the dawn of the universe. The galaxies studied show a redshift, appearing to be approximately 13 billion light-years old. Admittedly, according to scientific consensus, our universe was born some 13.8 billion light-years ago. But that means they would have reached maturity in just a few hundred million years after the Big Bang. The idea is simply inconceivable according to the standard cosmological model. These luminous groupings of stars are so massive that they are impossible in 99% of models of the early universe. What's more, they are astonishingly small, adding to the mystery surrounding them. So how do we explain their existence? How can galaxies from the early universe be in such an advanced state of growth, corresponding to billions of years of cosmic evolution? For the researchers, there had to be a mistake. Although every effort was made to locate it, it could not be found. Could it be that galaxies were formed more than 26 billion years ago? That's what Rahendra Gupta, assistant professor of physics in the Faculty of Science at the University of Ottawa, suggests. For this scientist, our universe could actually be twice as old as current estimates. This would not only shed new light on those impossible early galaxies, but also provide an explanation for the existence of stars like Methuselah, the stellar Doan that seems to have been shining longer than our universe. Rahendra Gupta is the originator of a new way of thinking and explains how his model stretches galaxy formation times by billions of years. In this hybrid model, he combines the evolution of Paul Dirac's coupling constants with a controversial theory, Zwicky's tired light theory. According to this theory, the redshift of distant galaxies is due not to the expansion of the universe, but to a gradual loss of photon energy. The photons would be progressively stripped of energy as they traveled the very long cosmic distance to the observer. As for Paul Dirac's coupling constants, these are fundamental physical constants that govern the interactions between particles. These may have changed over time. To sum up, according to the synthesis proposed by Professor Rahendra Gupta, the redshift exhibited by these incredible galaxies could be attributed to two phenomena. One is the expansion of the universe, the other is the fatigue of observed light. For the scientist, our universe could therefore be exactly 26.7 billion years old. The distant universe fascinates astrophysics experts and enthusiasts alike, all the more so when our Earth is hit by one of the most energetic cosmic rays ever recorded. Named Amaterasu, this strange cosmic ray was detected on May 27, 2021 by the Array Telescope Network. With its unrivaled power, it surpassed the first phenomenon of its kind detected in 1991, named Oh My God, and which motivated the Telescope Array project. Over the past 3 decades, more than 30 ultra-high energy cosmic rays have been detected, but none of them reached the power displayed by Oh My God until this latest discovery. Nicknamed Amaterasu after the Japanese goddess of the sun, this cosmic ray, composed of accelerated particles, is baffling scientists for several reasons. The first, of course, is its extraordinary power. The kinetic energy of just one of these particles has been estimated at that of a tennis ball thrown at nearly 150 kilometers per hour, or 90 miles per hour. While this ray, invisible to the naked eye, has remained in the shadows for the average person, it did not fail to panic scientists' measuring instruments when it was detected in the Utah desert. But even more disconcerting is the fact that nothing seems to be at the origin of such a phenomenon. Neither our galaxy nor neighboring galaxies. Indeed, after tracing its trajectory, the researchers were able to trace the source of this cosmic ray, or so they hoped. After all, it seems to come from a region of our universe that is virtually devoid of galaxies, and therefore relatively poor in matter. So how do we explain this flow of atomic nuclei and high-energy particles? What mechanism could have generated this extraordinary cosmic ray? Once again, to explain Amaterasu's origin, everyone has their own hypothesis. For some, it could have been particles emitted from our galactic surroundings, an event sufficiently discrete that no energy release or gamma-ray burst is detected by our instruments would then be the origin. This hypothesis calls into question the distant origin of the cosmic ray. A second theory suggests that the cosmic ray was deflected by an extragalactic magnetic field much more intense than originally thought. But the energy of the particles is so high that they should not have been affected by any magnetic field. Finally, the last hypothesis raises the possibility that this particle could confirm physics unknown to the standard model of particle physics. Critics also suggest that the Array Telescope may have overestimated the energy of the cosmic ray. What's more, the exact nature of the particle detected is still an unknown factor that can change everything. Is it a proton? Or, for example, an iron atom? As in so many other cases, this discovery only adds more mystery to our universe, which is proving to be ever more complex. One of the most recent discoveries once again challenges our understanding of the cosmos. A team of astronomers from the U.S. Green Bank Observatory, led by Karen O'Neill, has just made an unprecedented announcement. A unique galaxy, christened J0613+52, has just been spotted. What's special about it? It has no visible stars. So the image we have of a galaxy as an immense grouping of luminous stars bathed in gas and dust is not always accurate. So say the astronomers who have just inadvertently pointed their telescope in its direction. The discovery, which was totally fortuitous, was due to an input error. As Karen O'Neill explains, an operator inadvertently set the Green Bank telescope to the wrong coordinates. Without this oversight, the object 270 million light-years from Earth would have remained in the shadows, and with good reason. It's a low-surface brightness galaxy, which is extremely faint, even for this type of galaxy. Aware of this parameterization error, the astronomers nevertheless decided to take a closer look at this structure, which at first glance seemed insignificant. Their curiosity paid off, enabling them to make a completely unexpected discovery. They soon discovered that unlike other galaxies with low surface luminosity, this one is particularly rich in gas. Its chemical signature suggests that it contains abundant quantities of primordial gas. Like spiral galaxies such as the Milky Way, it contains mainly hydrogen and helium. After measuring the wavelength shifts, an undeniable fact emerged. This galaxy seemed to rotate in the same way as an ordinary spiral galaxy. This gas cluster has all the characteristics of our own Milky Way. Its mass, composition, and motion all match, except for one thing. There are no stars in this vast gaseous region. Scientists have a new enigma to solve. Have they discovered one of the first primordial galaxies, which underwent no transformations during its 13.8 billion years of existence? Why didn't this galaxy, so massive and holding these elements formed shortly after the Big Bang, enrich itself, like its counterparts, through stellar explosions in the course of its evolution? For Karen O'Neill, the gas in this structure is too diffuse to allow it to collapse in on itself under the influence of gravity. What's more, this galaxy is totally isolated from any other structure in its immediate vicinity. It seems never to have been disturbed by any other galaxy. But these explanations are not enough to demystify this unique and fascinating recent find. Indeed, it's unlikely that over such a long evolutionary period, no gravitational force has ever disturbed its peaceful existence. And yet, this is what it seems to demonstrate. To better understand the nature and dynamics of the early universe, scientists will have to be patient. Future discoveries of cosmic bubbles that have not undergone any reshaping should help elucidate this anomaly, but they still need to be detected, as they are particularly discrete. Now it's time to return to our magnificent planet Earth. Let's plan our return. However, there's one last anomaly we'll need to overcome if we're to return in the best possible conditions. Our trajectory must absolutely avoid a vast zone located between South America and the southwest of the African continent. You may not know it, but this area is known as the South Atlantic Anomaly. It turns out that in this region covering the globe, a curious phenomenon has been intriguing scientists for several decades. The intensity of the Earth's magnetic field is unstable and much lower than in the rest of our planet. If we were to cross this zone, the consequences could be terrible for our spacecraft. Bombarded by high-energy particles emanating from our sun, all onboard technology could suffer interference, or even worse, a disastrous malfunction. But rest assured, This phenomenon, although unexplained, is not new, and we know perfectly well how to dodge it to bring this fantastic voyage to a close. Let's start our exploration with the Sun. The Sun is the heart of our solar system. It's a yellow dwarf star, in other words, relatively small by universe standards. And yet, with a diameter of 1.39 million kilometers, or 870,000 miles, the Sun remains the largest object in our solar system. It's 109 times wider than our planet. Its size and mass are so great that its gravitational force holds all the planets in the solar system in orbit around it. The Sun is a fascinating star. It appears yellow to us from Earth, but is in fact white. It is 4.5 billion years old, but only halfway through its life. Within 5 billion years, it will swell, shrink, and then die out. The Sun's rays take 8 minutes to reach us. This means that if the Sun suddenly went out, we wouldn't know until 8 minutes later. The Sun is the origin of life on Earth. If there were no more Sun, we'd be in permanent darkness. Temperatures would plummet to minus 40 degrees Celsius or minus 40 degrees Fahrenheit within a few weeks, then to minus 100 degrees Celsius or minus 148 degrees Fahrenheit after several months. The oceans would be covered in ice. The Sun is indispensable to life on Earth, but it can also be dangerous. Have you ever heard that you should never look at a solar eclipse without protective glasses? The Sun emits powerful electromagnetic radiation in the form of both UV and X-rays. It also emits particles in the form of violent solar winds and regularly causes powerful solar flares. Our atmosphere protects us from these dangers. Because the Sun is composed mainly of hydrogen and helium, it is difficult to estimate its precise size. Its boundaries are blurred. According to studies published over the last 50 years, the extreme values of the Sun's radius differ by 1,500 kilometers or 930 miles. But studying the Sun is key to understanding our solar system. That's why NASA launched the Parker probe in 2018. Its objectives? To study the outer part of our star's atmosphere, understand the physics of the Sun and thus the formation and evolution of stars, learn more about solar winds and how to protect ourselves from them, on December 4th, 2019, a year and a half after the launch of the Parker probe, NASA announced some important discoveries. The Sun may be far more unstable than previously thought. The probe studied solar winds and recorded strange movements, rotations, deviations, and reversals. Solar winds are in fact extremely turbulent. In April 2021, the Parker probe was just 13 million kilometers from the Sun, the first time a space probe had come so close to our star. By the end of 2024, it should be grazing our star, just 6 million kilometers from its surface. It will finally be able to accurately study the Sun's temperature, its magnetic field, the composition of solar particles, and their movements in the solar environment. Perhaps we'll finally know why the solar corona can be up to 300 times hotter than the Sun's surface, with extreme temperatures of up to 1 million degrees. Just a few years after the launch of the Parker probe in February 2023, NASA made another surprising discovery while observing the Sun. Take a look at these images. A strange filament of plasma can be seen detaching itself from the Sun before spinning around a vortex towards the North Pole. For the moment, scientists can't explain this observation, but they do have an idea. Most likely, it has something to do with the Sun's changing cycle. Every 11 years, the Sun's magnetic field reverses, marking the start of a new cycle. The last cycle change took place at the end of 2020. With each cycle change, matter is disturbed and becomes more chaotic. ESA's Solar Orbiter satellite, launched in February 2020, may soon be able to provide us with some answers. There's still a lot to learn about the Sun, and each new discovery constantly challenges what we've already learned. Recently, in November 2023, a study revealed that the Sun may be smaller than previously thought. Methods for measuring the size of the Sun have evolved and become more refined. In the 1970s, we relied on total solar eclipses. 20 years later, experts relied on the oscillations caused by the Sun's waves to refine measurements. In the 1990s, it was discovered that the Sun was about 0.05% smaller than previously measured. More recent measurements have revealed that the Sun is even smaller, by a fraction of a percent compared with measurements taken in the 90s. A detail? No, because even the smallest fraction of a percent will be important for understanding the Sun's subtle internal structure. Let's move away from the Sun to continue our exploration of the solar system. The closest planet to the Sun is Mercury. It orbits at a distance of 0.4 astronomical units from the Sun, i.e., about a third of the distance that separates us from the Sun. And yet, it's not the hottest planet. The record is held by Venus, with its dense atmosphere that creates a powerful greenhouse effect. Mercury's surface temperature ranges from minus 180 degrees Celsius, or minus 292 degrees Fahrenheit at night, to 430 degrees Celsius, or 806 degrees Fahrenheit during the day. Although Mercury is the closest planet to the Sun, it is not the hottest. Mercury's average surface temperature is 167 degrees Celsius, or 332 degrees Fahrenheit, compared with Venus's average of 462 degrees Celsius, or 863 degrees Fahrenheit. Because Mercury has almost no atmosphere, sunlight is 7 times brighter and more intense than on Earth. If you were on Mercury, the Sun would appear 3 times bigger than it does from Earth. Barely larger than the Moon, Mercury is the smallest planet in the solar system. It is almost 20 times less massive than our own planet. It's also the fastest. It orbits the Sun in just 88 days at a speed of 47 kilometers per second or 30 miles per second. Mercury is a telluric planet, i.e. composed of a core, a mantle, and a crust. Its core, composed of iron and nickel, is particularly imposing, with a radius of over 2,000 kilometers or 1,300 miles, representing 85% of the planet's radius and over 40% of its volume. This makes Mercury the second densest planet in the solar system after the Earth. It is also the only telluric planet, along with our own, to have a magnetic field. Mercury's surface is riddled with craters and escarpments, just like the far side of the Moon. Yes, there's no atmosphere to stop asteroids, but there are also large, smooth expanses which could be the result of lava flows. As you can see, Mercury is an interesting planet, but it's not likely to harbor life. That's why only 2 probes have visited the planet closest to the Sun so far. Between 1974 and 1975, Mariner 10 took 2,700 photos of Mercury and mapped 45% of its surface. In 2008 and 2009, the Messenger spacecraft flew over Mercury 3 times before orbiting the planet. This mission mapped up to 95% of Mercury, photographing previously unknown areas. It collected 277,000 photos of Mercury and established a 3D model of its magnetosphere. A new mission is now underway to find out more about Mercury. The Bepi-Colombo mission from ESA and the Japan Aerospace Exploration Agency kicked off on October 19, 2018. 2 probes will be placed in Mercury orbit by the end of 2025, Mercury Planet Orbiter and Mercury Magnetospheric Orbiter. This is the riskiest mission ever undertaken by ESA because of Mercury's extreme temperatures, but also because of the energy required to reach the planet's orbit, which is very close to the Sun and subject to enormous gravitational forces. On June 27, 2022, Bepi-Colombo already delivered some impressive images of Mercury, taken at a distance of 800 kilometers or 500 miles from the planet. In these photos, you can see that Mercury looks a lot like the Moon. While we await the arrival of probes in Mercury's orbit, scientists have made some important discoveries in recent years. We already knew that Mercury shrank several billion years ago, but a study published in October 2023 has revealed that it's still doing so. Why is this? Mercury's crust is not a very good thermal conductor. It reflects back a large proportion of the sun's rays instead of absorbing them. As a result, despite temperatures that can reach over 400 degrees Celsius, or 752 degrees Fahrenheit, Mercury's gigantic core gradually cools, causing the planet to shrink. A bit like an apple that stunts as it ages. The Messenger probe had already shown that Mercury had shrunk by at least 14 kilometers or 9 miles in diameter over the last 3 billion years. Since then, even more recent signs of the planet's contraction have been discovered, showing that these processes are still at work. Shortly after these revelations in November 2023, another major discovery once again put Mercury in the spotlight. Salt glaciers were discovered near the planet's North Pole. In other words, this was the first sign of potential life observed on Mercury. According to the scientists' observations, these layers of salt could harbor some form of subterranean life, as in salt ponds on Earth. Some of Mercury's subterranean zones could therefore be habitable. What's more, these glaciers contain volatile compounds such as sodium, potassium, and sulfur, long thought to have been eliminated from Mercury's surface due to its proximity to the Sun. This discovery suggests that these salt layers were formed in the distant past, when Mercury's volcanoes were still emitting sodium-containing water vapors. Let's continue our journey through the solar system. Mercury's neighboring planet is Venus. Venus is the hottest planet in the solar system. It's a veritable hellish planet. Its thick atmosphere, rich in carbon dioxide and clouds of sulfuric acid, retains the sun's heat, creating an intense greenhouse effect. The average temperature on Venus's surface is 462 degrees Celsius, or 863 degrees Fahrenheit. This makes Venus the hottest terrestrial planet in the solar system. As Earth's neighbor, Venus is often considered our planet's twin. The two planets share many similarities. Like our planet, Venus is composed mainly of rocky material, contains some water, and has an atmosphere. Its size and mass are comparable to our own, as is its surface gravity. Scientists even believe that Venus was once habitable. It may even have contained oceans. It was the runaway greenhouse effect that turned it into the hell we know today. Today, temperature, pressure, winds, and sulfuric acid rain make Venus an uninhabitable world. Winds on Venus can reach 700 kilometers per hour, or 435 miles per hour, 300 kilometers per hour, or 200 miles per hour more than the strongest winds ever recorded on Earth. Scientists don't expect to find any form of life on Venus, but they continue to study the infernal twin in the hope of finding traces of past life. Or, to better understand how it evolved in this way. This is why Venus is of particular interest to researchers. At least 3 space missions should be dedicated to this planet over the next decade. In the meantime, scientists are continuing to work on existing images of Venus. In March 2023, researchers carried out a new analysis of images recorded over 30 years ago by NASA's Magellan probe. We now have evidence that Venus is the scene of intense volcanic activity. These radar images from the early 90s show what looked like the eruption of a lava lake. In the images, a crater can be seen changing shape, expanding, and overflowing with molten rock. According to the researchers, this is one of the most convincing pieces of evidence of volcanism on Venus to date. A shocking discovery, as we didn't expect to find this type of evidence before the 2030s. Above all, it's a first step towards learning more about Venus's volcanism, a crucial step towards a better understanding of how its runaway greenhouse effect came about. In November 2023, another discovery stirred the scientific community. This time, researchers detected atomic oxygen in the atmosphere of Venus. This discovery may help us better understand why, despite all their similarities, Earth and its neighbor are so different. Atomic oxygen was discovered at 17 sites in Venus's atmosphere, on both the day and night sides, at an altitude of around 100 kilometers or 60 miles. Be careful not to confuse molecular oxygen, or O2, with atomic oxygen, or O1. Molecular oxygen is present on Earth and we breathe it. It has not been found in the atmosphere of Venus. It's atomic oxygen, made up of single isolated oxygen atoms, rather than linked oxygen atoms, that has been found on Venus. It is also found on our planet at high altitudes. Atomic oxygen is created by a chemical process called photodissociation. This phenomenon occurs when a molecule dissociates under the action of light radiation. In other words, oxygen is converted from a molecular to an atomic form by solar photons. What would explain the presence of this compound in Venus's atmosphere? Venus's atmosphere may be composed mainly of carbon dioxide, or CO2. When sunlight strikes this CO2, a process of photodissociation takes place. The CO2 is split into atomic oxygen and carbon monoxide molecules. When these atoms migrate to the night side of Venus, they bond again to reform CO2. What can this discovery tell us, given that we already know that Venus is not habitable? In fact, this discovery is a major step forward in our understanding of Venus's atmospheric temperature profile, cooling processes, and wind speeds. For some paleontologists, atomic oxygen is a sign that Venus was once wet and warm. Just over 41 million kilometers from Venus lies planet Earth. Earth lies in what is known as the habitable zone of the solar system. The habitable zone corresponds to an area that is neither too far nor too close to the sun, so that liquid water can exist. The Earth is exactly in the habitable zone. It receives around 1,000 watts per square meter of energy radiated by the sun. But as we approach the sun, this amount of energy increases. Beyond Venus, it is too great. Water cannot remain in liquid form and will vaporize. Beyond Mars, Earth's other neighbor, the planets no longer receive enough energy from the sun. Water exists only in the form of ice. The presence of liquid water is the first criterion for a planet's habitability. Like the other planets in the solar system, the Earth revolves around the sun. One complete revolution lasts 365.25 days. To express the distances between celestial objects, a unit of length was invented. This is the astronomical unit. It corresponds approximately to the distance between the Earth and the Sun, i.e., about 150 million kilometers, or 93 million miles. The Earth rotates on itself in 23 hours and 56 minutes. While Mercury and Venus have no satellites, the Earth does. The Moon. The Moon forms shortly after the Earth. It is the gravitational interaction of our planet with its satellite that creates the tides and stabilizes its axis of rotation. The Earth is the densest planet in the solar system. Compared to Mercury, Venus, and Mars, Earth is the largest and most massive of the 4 terrestrial planets. 71% of its surface is covered by water, or ice around the poles. Over the course of an Earth year, the distance between the Earth and the Sun varies. This is because the Earth's orbit around the Sun is elliptical rather than perfectly circular. On the night of January 3rd, 2024, the Earth was closest to the Sun, at a distance of around 147 million kilometers, or 91 million miles. We say it was at its perihelion. Perihelion, or closest distance to the Sun, is the opposite of aphelion, the maximum distance between the two. The Earth will reach its aphelion on July 5, 2024. The distance separating us from the Sun will then be 152 million kilometers, or 94 million miles. So there's a difference of 5 million kilometers, or 3 million miles, between perihelion and aphelion. However, this is not a determining factor in the Earth's seasons. What determines whether we're in summer or winter is the tilt of the Earth on its axis of rotation. A recent study has shown that the Earth is not as special as we think. Life could well have arisen on another planet. In fact, the slightest minor change in the history of our solar system could have given rise to life elsewhere than on this planet. Vertiginous when you think about it. Above all, scientists maintain that the habitability of a planet is not a permanent factor. Venus and Mars may have been habitable in the past. Today, however, they are far from our idea of a hospitable world. The very concept of the habitable zone is more complex than we once thought. The Sun's habitable zone is not the same as that of Proxima Centauri, for example, the nearest star in the solar system. In fact, a star's habitable zone depends on a number of factors: the size of the star, the energy released, the atmosphere of the planets. Plate tectonics are also a feature of the Earth that other planets in the solar system do not possess, making it a flexible and adaptable world. In fact, researchers believe that if Mars had a tectonic plate system, it could be habitable. Mars, the red planet, here we come. Mars is the fourth planet from the Sun, the last planet before the asteroid belt, and the furthest from the Sun among the telluric planets of our solar system. Mars is 10 times less massive than the Earth. Like Mercury, it has similarities to the Moon, with craters and impact basins, volcanoes, rifts, valleys, dunes, and polar caps. Mars is home to the highest volcano in the solar system, Olympus Mons. Mars is also home to the world's largest canyon, Valles Marineris. Today, Mars is much less active than in the past. Volcanic eruptions are very rare. None have been observed by man. In 2013, a team of scientists from the University of Arizona published a study in the journal Nature Geoscience suggesting that a volcanic eruption occurred on Mars around 500,000 years ago. The team analyzed data from NASA's Mars Reconnaissance Orbiter and discovered deposits of volcanic ash and gas in a region called Cerberus Fossae. These deposits were similar to those observed on Earth during recent volcanic eruptions. Thus, significant volcanic activity could have taken place 1 million years ago. There are still a few minor geological events: landslides, earthquakes, geysers in the polar regions. Since the 19th century, scientists have been looking for traces of life on Mars. The first mission to explore Mars by flyby dates back to 1965 with NASA's Mariner 4 probe. Since then, knowledge of Mars has progressed enormously. It is now known that the red planet is not home to any multicellular life forms, but that there could be single-cell life somewhere in the bowels of Mars. Scientists therefore continue to search for traces of microorganisms on the red planet. But not only that, the latest studies of Mars also seek to better understand its geological development. On May 4th, 2022, NASA's InSight probe recorded the strongest earthquake ever recorded on Mars, or any planet other than Earth. A magnitude 4.7 earthquake was recorded over a 6-hour period, an unexpected finding given that Mars has no tectonic plate movements. This violent tremor could have been caused by a meteorite. However, the scientists found no evidence of a collision on the planet's surface to suggest this. Such an impact would have caused a crater 300 meters or 1,000 feet in diameter, with dust spewing out into space. But none of this was found. It would seem then that this magnitude 4.7 earthquake originated from Mars' internal activity. Solving this mystery will tell us more about the magma currents at work on Mars, its geological formation, and the causes of the loss of its magnetic field over billions of years. Mars still has plenty of surprises in store for us. A few months later, in October 2022, NASA discovered a gigantic meteorite impact crater on Mars. Its dimensions are impressive: 150 meters, or 500 feet in diameter, and 21 meters, or 70 feet deep. It's the largest meteorite impact crater ever discovered on a planet. To cause this impact, a meteorite of around 12 meters, or 40 feet, with a mass of between 250 and 650 tons, would have rushed into Mars at a speed of 7.5 kilometers per second, or 5 miles per second. This is consistent with an impact dating back to December 24, 2021, which had caused a magnitude 4 earthquake. The tremors caused by the impact brought out chunks of ice from beneath the Martian surface. Could this be a clue to the presence of underground liquid water on the red planet? We now know that Mars is an icy planet. It is covered by permanently frozen ground. All that remains now is to discover what this icy water contains, which will be the focus of future Mars missions. On February 8, 2023, NASA announced that it had discovered the best evidence yet of the existence of lakes on Mars. An announcement that astonished many. Mars is an arid, dry environment with such low atmospheric pressure that even if temperatures allowed liquid water, it wouldn't persist. But in reality, the red planet wasn't always so barren. In fact, shortly after its formation some 4.5 billion years ago, Mars was very similar to Earth. Its atmosphere was denser and its temperatures warmer. Hundreds of millions of years ago, liquid water even carved out canyons on Mars. In February 2023, NASA discovered traces of waves on the planet's surface. The Curiosity rover found rocks whose surface is marked by undulations. These rocks have been miraculously preserved, giving us a glimpse into the red planet's past. All that remains now is to analyze these undulating rocks, which the rover has not yet been able to do due to their hardness. Six months after this discovery, another major breakthrough shook the scientific community. On August 9, 2023, a study was published in the journal Nature. This study revealed potential traces of life on Mars. In fact, they are fossil evidence of a cyclic climate. In other words, evidence that Mars was once organized into dry and wet seasons just like Earth. A regular cyclical climate is an environment conducive to the organization of simple organic molecules into complex organic compounds. In a word, conducive to life. Mars still holds many mysteries. Let's continue our exploration of the solar system, heading to the fifth planet from the Sun, Jupiter. On our way, we come across the asteroid belt. It was formed around 4.6 billion years ago, at the same time as the solar system. It's made up of several 100,000 asteroids that didn't aggregate to form planets. Or rather, small bodies of the solar system, i.e. celestial objects that are neither planets nor satellites. The hundreds of thousands of small bodies that make up the asteroid belt vary enormously in size. They range in size from a speck of dust to several hundred kilometers in diameter. Among these small bodies, there is just one dwarf planet, Ceres. With a diameter of 950 kilometers or 590 miles, Ceres alone represents almost a third of the mass of the asteroid belt. And yet, it's a small dwarf planet, 14 times less massive than Pluto. It's also the only spherical object in the asteroid belt. The other objects are all irregularly shaped. Ceres has a rocky core, a mantle of water ice representing 25% of the planet, and a rocky crust with salt deposits. A structure similar to that of the telluric planets of the solar system. Discovered as early as 1801, it is now of interest to scientists for several reasons. First, it is thought to be a protoplanet. If so, it could provide clues to the formation and evolution of planets in the solar system. Secondly, Ceres may have once sheltered an ocean of liquid water. What's more, data collected during the flyby of this dwarf planet by the Dawn probe, launched by NASA in 2007, had aroused the curiosity of scientists. The Dawn probe was placed in orbit around Ceres in 2015. In 2017, it detected the presence of complex organic molecules. The origin of these compounds, from the hydrocarbon family, had not been fully elucidated. Scientists had put forward several hypotheses, concluding that they could have been brought by comets or formed from compounds present in salt water. A study in October 2023 has reignited the debate. New analyses have shown that the origin of these compounds could be endogenous. In other words, they could have formed on Ceres thanks to the presence of water. So, at the heart of this dwarf planet in the asteroid belt, there could be a reservoir of organic compounds. Another asteroid in the asteroid belt between Mars and Jupiter has been in the news recently, 16 Psyche. 16 Psyche is one of the most massive asteroids in the asteroid belt. It is 226 kilometers, or 140 miles wide, and very heavy. Composed of between 30% and 60% metal, it represents just under 1% of the mass of the entire asteroid belt. According to NASA, this asteroid has a core of iron, nickel, and gold. This could be the residual core of a primitive planetesimal. In other words, the metallic core of a dead planet. This asteroid could then help us better understand the composition of the Earth's core. The Psyche mission was launched in October 2023 to find out more. It will take 6 years for the space probe to reach 16 Psyche. Exploration of this promising asteroid will therefore not begin until August 2029. At that point, The space probe's mission will be to map the asteroid and study its properties. Let's resume our journey through the solar system. We're now about 779 million kilometers, or 485 million miles from the Sun, beyond the asteroid belt. You're looking at the largest planet in the solar system, Jupiter. Jupiter is a gas giant. It is larger than all the other planets in the solar system combined, with a radius 11 times that of the Earth and a mass 318 times greater. It's so massive that it's visible to the naked eye from Earth, and has been known about since prehistoric times. It is, after the Sun, Moon, and Venus, the fourth brightest object in our night sky. Jupiter's composition is similar to that of the Sun, mainly hydrogen and helium. Jupiter's atmosphere is very thick. Because it's a gaseous planet, it's difficult to know where the boundary lies between its surface and atmosphere. Jupiter may contain a small rocky core like Earth's, but scientists have yet to prove this. Jupiter has the shortest day of any planet in the solar system. It completes a full revolution on itself in less than 10 hours. Because of this ultra-fast rotation, Jupiter is flattened at the poles and domed at the equator. On the other hand, Jupiter's years are long. 1 year on Jupiter is equivalent to just under 12 Earth years. Jupiter, its 95 moons and rings, are known as the Jovian system. Jupiter's moons are satellites attracted by its gravitational force. Scientists have given names to some 50 of these moons. Jupiter's influence extends even beyond the Jovian system. A group of asteroids known as Jupiter's Trojan asteroids share its orbit around the Sun. In 2023, several discoveries were made on Jupiter. In February 2023, astronomers searching for a 9th planet at the edge of the solar system came across 12 new Jovian moons. These moons are not as impressive as Ganymede, Jupiter's largest moon. The moons are quite small, ranging in diameter from 1.5 kilometers or 1 mile to 5 kilometers or 3 miles. They were discovered almost by accident. Discovering new moons around Jupiter is complicated, not only because Jupiter is so bright that its brilliance obscures that of small moons, but also because it takes powerful telescopes with a wide enough field of view to capture the immense Jovian system. But Jupiter found itself in the telescope sights of scientists whose mission it was to find the 9th planet. Thanks to the high-performance tools used by the scientists, only 4 images were needed to cover the entire Jovian system. The first signs of these new moons were detected in March 2017, but it took some time to confirm their existence. Of these 12 moons, 9 are retrograde, meaning they revolve around the Sun in the opposite direction to the Earth and most other planets and asteroids. These moons are therefore thought to be small lunar debris, the result of collisions that destroyed much larger moons, and to have been captured by Jupiter. In other words, these bodies were not born in the Jovian system, but were drawn there by Jupiter's impressive gravitational force. Jupiter's moons are a prime target for researchers, who are taking a close interest in them in the hope of finding traces of life. On April 14, 2023, the JUICE probe lifted off for Jupiter. The probe is named JUICE for Jupiter Icy Moon Explorer. In other words, its main objective is to explore Jupiter's icy moons. It will enter the Jovian system in 2031, flying over the moons Callisto, Ganymede, and Europa. It will then orbit Ganymede, Jupiter's largest satellite, for ideally 1 year. By September 2023, discoveries had been made on Europa, the smallest of the 4 Galilean moons. The James Webb Telescope found traces of carbon dioxide on the moon's surface. This discovery supports the hypothesis that Europa contains an underground ocean of water. This ocean would probably be salty, with a depth of around 100 kilometers or 60 miles. If the CO2 detected on Europa's surface does indeed come from this ocean, then Europa could join Saturn's moon Enceladus at the top of the list of most habitable places in the solar system. James Webb made another important discovery in October 2023. His images revealed a previously unseen feature of Jupiter's atmosphere. In this photo, you can see an incredible high-speed jet stream stretching over 4,800 kilometers or 3,000 miles above the main cloud decks north of Jupiter's equator. Until now, this feature has always been seen as hazy mists in Jupiter's atmosphere. But the incredible precision of the James Webb Telescope has given us a clearer picture. This discovery is one step closer to understanding the interactions between the layers of Jupiter's atmosphere. Let's continue our journey through the solar system. We're now approaching Jupiter's neighbor, Saturn. Saturn is the second largest planet in the solar system. It is best known for its magnificent rings, which average 10 meters or 30 feet in thickness, but in some places stretch to 100 meters or 330 feet. Scientists believe that Saturn didn't always have these rings of ice and dust. They may have been created when one of Saturn's first moons collided with the young planet. Around 100 million years ago, a moon orbited Saturn. This moon eventually came very close to the planet, orbiting it faster and faster. The acceleration eventually caused the moon to explode, its fragments scattering around Saturn to form a disk. In the distant future, it is highly likely that Saturn will gradually lose its rings, disappearing completely in around 300 million years. A Saturnian day lasts 10.5 hours, but a Saturnian year lasts 29.5 Earth years. Saturn is the planet with the most moons in the solar system. After the discovery of 12 new moons around Jupiter in February 2023, Jupiter was the planet with the most moons. Saturn had 83. But in May 2023, 62 new Saturnian moons were discovered, bringing the planet's total number of satellites to 145. How were these moons discovered? Moons are difficult to detect, not only because they move, but also because they are often so small that they don't reflect enough light. To discover these 62 moons, scientists took multiple images of a large window of sky every 5 minutes for 3 hours over a 3-year period with the Canada-France-Hawaii telescope. These images were then combined to form a single image. And then, surprise, 62 new moons of Saturn were revealed. These 62 moons are known as irregular. Like the 12 moons discovered around Jupiter in early 2023, they were formed before being captured by Saturn's gravitational influence. They are the result of various collisions, the oldest of which date back billions of years. Further discoveries were made at the end of 2023, revealing more of Saturn's hidden mysteries. On October 22, 2023, a mysterious phenomenon was photographed by Hubble: spots on the planet's rings. These mobile, seasonal spots are known as ring rays. They had already been observed by the Voyager 1 probe in 1981, then by the Cassini probe. For the moment, researchers are unable to explain their origin. Perhaps they result from the interaction between the solar wind and Saturn's magnetic field. This would generate powerful electrostatic forces, lifting dust and ice above the rings. What we do know is that the number of spots and their contrast vary according to Saturn's seasons, which last 7 years each. Right now, as we approach Saturn's equinox, the ring rays should increase in frequency and become darker. But there is currently no theory to predict when these rays will appear. Another mystery: while the spots usually appear on only one side of the ring, Hubble was able to observe them on both sides. And they're not as small as they look. They can extend far beyond the Earth's diameter. Shortly after the release of this Hubble photo, another discovery, this time by ESA, caused quite a stir. According to ESA, a cosmic phenomenon is set to occult Saturn's rings for 7 years, an extremely rare event. This cosmic phenomenon is linked to Saturn's orbital motion. On August 27, 2024, Saturn will reach its brightest point and most prominent size. Saturn's gradual inclination will end in March 2025. After this date, Saturn's rings will no longer be visible. Very recently, on February 7, 2024, a striking new discovery was published in the journal Nature. This time, the discovery concerns a moon of Saturn that we don't hear much about. It's called Mimas. Mimas is the smallest of Saturn's 7 main moons. It has joined the very exclusive club of habitable moons alongside the Saturnian moons Titan and Enceladus, and the Jovian moons Europa and Ganymede. And why? Because it too is said to harbor an ocean beneath its surface. An unexpected discovery, to say the least. Mimas is said to harbor an ocean 72 kilometers or 45 miles deep, beneath a frozen crust 24 kilometers or 15 miles thick. This sea would have appeared less than 25 million years ago and would account for more than half of Mimas's total volume. As early as 2014, the possibility that Mimas was home to an ocean had been raised. The moon oscillated unexpectedly around Saturn. In fact, Mimas's orbit has drifted by around 10 kilometers or 6 miles in 13 years. This has now been confirmed. However, Mimas's ocean would be relatively young from an astronomical point of view. In other words, it's likely that life hasn't had time to appear there. Something to keep an eye on. Let's continue our journey through the solar system to the 7th planet from the Sun, Uranus. Uranus is the 3rd largest planet in the solar system after Jupiter and Saturn. It is 4 times larger than the Earth. It is also the coldest planet, along with its neighbor Neptune. Both are what we call icy giants. Its atmosphere is composed mainly of hydrogen, helium, methane, and ammonia. Its magnificent blue-green color is due to methane. One of Uranus's particularities is that its axis of rotation is tilted by 98 degrees Celsius or 210 degrees Fahrenheit. This gives the planet the impression of rolling in its orbit, and it represents the same pole to the Sun for 42 years. Like Saturn and Jupiter, Uranus has 13 rings made of rock and dust. But these are very dark. Uranus also has 27 known moons. The 5 largest known moons of Uranus are Titania, Oberon, Umbriel, Ariel, and Miranda. These 5 moons have particularly attracted the attention of researchers in recent years. Why shouldn't they, like the moons of Saturn and Jupiter, harbor underground oceans? The Voyager 2 probe flew past Saturn, Uranus, and Neptune in the 1980s. In fact, it was the only probe to come so close to the 2 icy planets. The data it collected is still being studied by scientists. And because water has been found in such unlikely celestial bodies as Ceres, Pluto, and Mimas, hopes have naturally turned to the moons of Uranus. The findings of recent studies have rekindled these hopes. With the exception of Miranda, these moons could indeed harbor an underground ocean, especially the 2 largest, Titania and Oberon, which could harbor an ocean that is thicker and warmer than the other 2 moons, and therefore potentially inhabited. Unless, of course, all these moons harbor only residual oceans or relics of former oceans. So, inhabited oceans or residual oceans? Future missions to the moons of the largest icy giant planet could tell us more. Take a look at this photo of Uranus. It was taken on February 6, 2023 by the James Webb Telescope. In this photo, you can see the icy giant surrounded by several moons and 11 of its 13 dust rings. Some of these rings had not been photographed since 1986. Future images should reveal 2 more outer rings discovered by Hubble in 2007. With this photo, James Webb delivers essential information that will help us better understand Uranus's seasons. We can also see Uranus's famous and mysterious polar cap. Because Uranus is inclined at 98 degrees to the plane of its orbit, its seasons are extreme. At the poles, days and nights last for years. The polar cap disappears in summer, when it's in full sunlight, and mysteriously reappears in autumn, when the pole is plunged back into darkness. The photo also shows 2 bright clouds that could be storms. In December 2023, the telescope revealed another image of Uranus to clarify these observations. This new image enabled us to observe certain features of Uranus in greater detail: the white inner cap and the dark band at the bottom of the polar cap towards lower latitudes. Several storms are also visible near the southern edge of the polar cap. Astronomers are eager to observe the changes that are sure to occur in 2028, when Uranus reaches its next solstice. On May 23, 2023, further images of Uranus were published. This time, these were not James Webb photos, but a combination of shots taken in 2015, 2021, and 2022. astronomers have taken advantage of a particularly propitious period to observe Uranus. It's only since 2015 that we've been able to observe Uranus's poles properly, for the first time in almost a century. That's right, it takes the icy giant 84 years to circle the solar system. Using the Very Large Array Telescope, astronomers have studied Uranus's polar atmosphere under the radio wave spectrum and detected a polar cyclone, a first. And above all, another indication that Uranus is far more dynamic than previously thought. The discovery also confirmed that all the planets in the solar system share a common feature: vortices or whirlpools at their poles, except Mercury, whose atmosphere is too tenuous. NASA has made Uranus one of its priorities since 2023. An observation program has been launched until 2032. It is called Uranus Orbiter and Probe. We are now 4.5 billion kilometers or 3 billion miles from the Sun. The second ice giant, Neptune, is the furthest planet from the Sun. At times, it's even further away than the dwarf planet Pluto. It's so far away that the only spacecraft to visit Neptune, Voyager 2, took around 12 years to get there. It's the fourth largest and third most massive planet in the solar system. It is 17 times more massive than Earth. It is also the densest giant planet. Neptune is not visible to the naked eye. It was therefore discovered by deduction rather than direct observation, unlike the other planets in the solar system. Based on astronomers' calculations, it was first observed in 1846. Neptune takes around 165 Earth years to orbit the Sun. A day on Neptune lasts about 16 hours, and each season lasts 40 years. Neptune has a solid core of silicates, nickel and iron, equivalent to 1.2 times the size of the Earth. This core is surrounded by a hot fluid composed of icy materials such as water, methane, and ammonia. Neptune has no solid surface. Its atmosphere is composed mainly of hydrogen and helium, with traces of methane. It is the windiest planet in the solar system, with winds reaching up to 2,100 kilometers per hour or 1,300 miles per hour. Neptune's Great Black Spot has long intrigued scientists. This enormous storm in the planet's southern hemisphere was spotted during Voyager 2's flyby in 1989. Its winds reached speeds never before recorded on any planet in the solar system. It had completely disappeared by 1994. Another similar spot appeared in 2016, this time in Neptune's northern hemisphere. In September 2022, the James Webb Telescope photographed Neptune with its rings. This unprecedented photo shows not only Neptune's thin rings, but also some of the planet's moons. In this image, Neptune sparkles with a blinding brilliance, like a faceted ball. It shines brightest at higher latitudes and at the poles. Scientists believe that these particularly bright areas are active regions, reflecting more sunlight than the planet's other methane-rich regions. In the image, Neptune is streaked with fine white lines, which NASA believes are signs of atmospheric circulation. In fact, these lines represent matter moving down from the high latitudes towards the equator as it heats up. A wider view, also broadcast by James Webb, shows Triton, Neptune's largest moon, shining even brighter than Neptune itself. In the image, Triton looks like a star. In fact, Triton shines so brightly because it is covered in nitrogen ice, which causes it to reflect around 70% of the sun's light. A total of 7 moons can be seen out of Neptune's 14 known satellites. Triton, then inside Neptune's rings, Galatea, Naiad, Thalassa, Despina, and finally Larissa. The colors are not bright, as the image was taken in the infrared. We tend to say that Neptune is dark blue and Uranus light blue. Is this true? According to recent images and the analysis of researchers, no. In fact, the 2 icy giants are both dark blue. In fact, both icy giants are the same color, a light shade of greenish blue. In fact, at the time of Voyager 2 and the first images of Neptune, scientists had forced the contrast to better distinguish clouds and winds on the images. In other words, Neptune had been artificially made much bluer than it really was. We knew this at the time, but the accuracy was lost over time, until it was thought that the bright blue was Neptune's true color. In January 2024, researchers at Oxford University re-established the truth by publishing photos of the 2 planets in their true colors. Another mystery hovers around the 2 icy giants: diamond showers. As early as the early 80s, it was thought that diamond hearts might exist within Uranus or Neptune. These diamond cores would form under the action of the enormous pressures acting on the carbon compounds detected in their atmosphere. More recently, studies have been carried out on the formation and appearance of diamond showers in icy giants. That is, Neptune and Uranus, but also those outside the solar system. The results were astonishing. Diamonds could appear at lower temperatures and pressures than previously thought. There could well be diamond showers on Neptune and Uranus, in the shallow layers of their atmospheres. We have completed our exploration of the planets of the solar system, but we haven't reached the end of our adventure yet. We still have a few objects to explore and a few mysteries to unravel. Let's take a closer look at Pluto. Pluto was long considered the 9th planet in the solar system until 2006, when it was classified not as a planet, but as a dwarf planet. Let's take a step back in time. Years before Pluto's existence was discovered, it had already been suspected. Researchers had identified anomalies in the motions of Uranus and Neptune. In fact, the 2 planets were moving through space as if another object were disrupting their trajectory. Astronomers searched the skies for years, looking for what they called Planet X. What they didn't know was that it was a planet. What they didn't know was that these disturbances were not due to the presence of a 3rd planet interacting gravitationally with them. Rather, they were due to an incorrect estimate of Neptune's mass. In any case, a 9th planet was discovered in 1930. It was soon realized that it was too small to have influenced the motion of Uranus. Little by little, researchers refined their knowledge of this 9th planet called Pluto. It soon became clear that Pluto differed in size from the other 8 planets in the solar system. Pluto is very small indeed. Its diameter is just 2,376 kilometers, or 1,500 miles, half that of Mercury, itself very small compared to the other planets in the solar system. What's more, Pluto's orbit is very inclined and flattened. It moves through space more like a comet than a planet. But Pluto isn't a comet, it's spherical in shape, and like its neighboring planets has satellites. So we had to ask ourselves the following question: does Pluto meet the criteria that make a planet a planet? These criteria are as follows. The planet orbits the Sun. The planet has sufficient gravitational force to have a spherical shape. The planet has sufficient mass to clear its orbit of debris. Pluto meets only the first two criteria. It has therefore been downgraded to a dwarf planet. Since 2006, there have been 8 planets in the solar system. These are the 8 planets we explored on this trip: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The solar system also includes 5 dwarf planets: Ceres, Pluto, Haumea, Makemake, and Eris. Pluto never ceases to intrigue researchers, not least because of its chaotic orbit. That's right, Pluto's orbit is very inclined compared with other planets in the solar system, and seems to be subject to disturbances over short periods. Pluto takes 248 Earth years to orbit the Sun. It is separated from the Sun by 6 billion kilometers, or 4 billion miles. On average, because there is a difference of 20 astronomical units between its aphelion and perihelion, this means that every orbital period, Pluto orbits closer to the Sun than Neptune for around 20 years. Despite extensive research, scientists have been able to pinpoint the cause of Pluto's chaotic orbit. One of the most commonly accepted theories is that of planetary migration. In other words, Pluto was pulled into its resonance by Neptune as it migrated to the outer regions of the solar system early in its history. However, this theory does not explain Pluto's inclined orbit. In October 2023, another surprising discovery was made on Pluto, that of a cryovolcano. In other words, an ice-spitting volcano. This volcano, said to be the size of a country like Cyprus, is said to have erupted several times. In the process, it would have spewed out some 1,000 square kilometers, or 385 square miles of ice, enough to bury a megalopolis like Los Angeles. This discovery was made thanks to data from the New Horizons probe, launched by NASA in 2015 to study the structure of Pluto and its satellites. This probe had come within 11,000 kilometers, or 6,900 miles of Pluto, in July 2015. This led to the discovery of the Kilad's crater, which extends over 44 kilometers, or 27 miles. It could be the result of collapses caused by eruptions and is thought to be a few million years old. Proof not only of Pluto's intense seismic activity, but also of its geological variety. On Pluto, cryovolcanoes have been found, as well as icy plains, ridges several kilometers high, and even a heart-shaped glacial region 2,000 kilometers, or 1,300 miles wide. Beyond Neptune's orbit lies the Kuiper Belt. This is actually a ring-shaped region populated by almost 100,000 icy bodies over 100 kilometers, or 60 miles in size, and several billion comets. The Kuiper belt is larger than the asteroid belt. It is 20 times wider and between 20 and 200 times more massive. Like the asteroid belt, it is made up of small bodies left over from the formation of the solar system. But unlike the asteroid belt, which has just one dwarf planet, the Kuiper belt has at least 3: Pluto, Makemake, and Haumea. The dwarf planet Eris is not considered part of the Kuiper belt. Kuiper belt objects are mostly made up of frozen volatile compounds such as methane, ammonia, or water. The first Kuiper belt object to be discovered was named QB1. It was discovered in 1992. The study of the Kuiper belt is important, not only because it surely contains clues to the early solar system, but also because it is thought to be the source of short-period comets. It would therefore be a kind of reservoir for this type of comet, in the same way as the Oort cloud is a reservoir for long-period comets. For these reasons, the Kuiper belt was explored by the New Horizons probe, which flew past it in 2019. At the end of May 2023, data from its observations were presented at a scientific conference. Surprising data suggesting that there could be a second Kuiper belt. However, the researchers behind this discovery caution against jumping to conclusions. For the moment, it's just a hypothesis. Another discovery concerning the Kuiper belt was made in September 2023, this time by Japanese astrophysicists. It would appear that the Kuiper belt is home to a planet larger than the dwarf planets listed there. This hypothetical planet has not been observed directly, but deduced from the strange, steeply inclined orbits of certain Kuiper belt objects. This suggests that these objects are under the gravitational attraction of another larger body. The presence of a planet is one hypothesis among others, but it is consistent with the simulations. If it exists, this planet would have a mass 1.5 to 3 times that of the Earth. Its inclination would be around 30 degrees, and its orbit would take it to a distance of between 250 and 500 astronomical units from the Sun. All that remains is to confirm the presence of this planet. This planet would be different from the 9th planet, whose existence scientists are trying to prove. There could in fact be a 9th planet beyond Neptune's orbit. This would explain the orbits of certain objects in the Kuiper belt. But this hypothesis still divides scientists. We'll have to wait for more concrete proof before it is unanimously accepted. What lies beyond the Kuiper belt? Because the Kuiper belt doesn't mark the end of the solar system, the Oort cloud is still hypothetical, as it has never yet been observed. This cloud would occupy a vast zone of space between the outer edge of the Kuiper belt at around 50 AU and extend out to 1 light-year, the distance it would take light to travel 1 year. The cloud would be subdivided into the spherical outer Oort cloud and the torus-shaped inner Oort cloud. The question of the limits of the solar system is a subject of fascinating debate in the astronomical community, revealing that the boundary of our planetary system is not a fixed notion, but rather a fluctuating concept, depending on the criteria chosen to define it. The first perspective, popularized by the historic voyages of the Voyager probes, focuses on the heliopause as a marker of the solar system boundary. The heliopause represents the boundary where the solar wind, a stream of energetic particles emitted by the Sun is stopped by the interstellar medium. In 2013, Voyager 1 crossed this boundary some 19 billion kilometers, or 12 billion miles from Earth, marking humanity's first foray into interstellar space. However, this definition is based primarily on the Sun's electromagnetic influence, not its gravity. Another definition, supported by many astronomers, takes into account the Sun's zone of gravitational influence. In this perspective, the limits of the solar system extend to the outer edge of the Oort cloud. To better grasp the immensity of our solar system, let's imagine it on a reduced scale, with the Sun represented by a yellow ball 1 centimeter in diameter instead of its actual 1.4 million kilometers, or 870,000 miles. In this miniature perspective, the Earth, which is 109 times smaller than the Sun, would be transformed into an almost imperceptible 0.1 millimeter grain of sand, located 1 meter away from our miniature star. This distance would correspond to 150 million kilometers, or 93 million miles in space, or 1 astronomical unit, AU. On this scale, Jupiter would be 5 meters or 16 feet from the Sun, Neptune 30 meters or 98 feet, and Pluto would float at around 40 meters or 130 feet, with a Kuiper belt stretching between 30 and 55 meters, or between 98 and 180 feet from our miniature star. However, even on this scale, we would not yet have reached the outer reaches of the solar system. The Oort cloud would mark the outer limit, extending to around 100 kilometers or 62 miles from our miniature Sun. So, if the Sun were compared to a small yellow marble, its gravitational influence would extend over a sphere with a radius of 100 kilometers or 62 miles. To put things into perspective, Proxima Centauri, the nearest star to our solar system, would be 400 kilometers or 250 miles away in this reduced model. Our journey is coming to an end. Through this exploration, you will have understood that our solar system is very complex, and yet it's far from unique. In the vastness of our universe, the solar system is just one of many planetary systems. Each of these planetary systems consists of a star with planets in orbit. To date, over 3,200 stars with planets orbiting them have been discovered, and that's just the beginning. So yes, the solar system is far from unique, but one wonders how rare its configuration is on the scale of the universe. And indeed, of all the planetary systems in our universe that have been studied, it appears that there is a wide variety of possible structures. So far, we haven't found anywhere else a structure like that of our solar system, with only dense, rocky planets closer to the star on one side and only gas giant planets further away on the other. Could our solar system be an exception? Perhaps, because scientists believe that the arrangement of planets in our solar system is indeed due to chance. A happy coincidence for us. Let's begin our journey with a visit to Isis, more aptly named HD 189773b. The discovery of this exoplanet dates back to 1991. The Hipparcos satellite measured its transit in front of its host star. However, Its discovery was only confirmed in 2005 by a team of European astronomers. Located in the Little Fox constellation, just 63 light-years from Earth, this beautiful blue planet seems like the perfect vacation spot. But think again. Behind its beautiful, peaceful-looking azure hue, believe me, you'd better not try to land there. It's a hot, Jupiter-type exoplanet orbiting the orange dwarf star in just 2.2 days, and is therefore very close to it. Because of its relatively small distance from our Earth, it is one of the few exoplanets to have revealed its radius, approximately 1.26 times that of Jupiter, and its mass, approximately 1.15 times that of Jupiter. The clouds in its atmosphere, contrasting with its bright blue, could tempt us to make a landing and explore the planet's surface more closely. But a closer look at the atmospheric data reveals that the planet's atmosphere is far less welcoming, not to say terrifying, than we might have imagined. The winds that sweep across this gas giant blow at supersonic speeds, reaching over 7,000 kilometers per hour, or 4,400 miles per hour, more than 7 times the speed of sound. This parameter alone would propel us into an infernal spiral around the planet, with no way out. In this apocalyptic atmosphere, another phenomenon would have even more terrible consequences. Isis contains a large quantity of silicon, which diffuses this splendid bluish hue. Exposed to destructive temperatures of around 1,300 degrees Celsius, or 2,400 degrees Fahrenheit, these silicon particles condense, transforming into innumerable pieces of sharp glass. In short, this planet is far from the oasis it first appears. Quite the contrary. A deluge of mist and ice covers its surface, carried along by the cataclysmic winds that swirl relentlessly around it. Although particularly attractive, you'll understand how vital it is to keep our distance. Isis made headlines in 2007, however, when a team of astrophysicists announced that they had detected the presence of water in its bubbling atmosphere. This conclusion was based on the observation of the red spectrum of its light, passing through the atmosphere during its transit in front of the host star, using data collected by the Spitzer and Hubble telescopes. This news confirmed an idea established by theoretical planetologists, namely that gaseous exoplanets could be rich in water. While not all researchers agreed with this assertion, another Isis study did indeed show that an absorption line characteristic of the water molecule had been detected. This technique could, in future, enable scientists to detect the presence of this vital element on Earth-like exoplanets. Let's turn now to an equally inhospitable exoplanet whose remaining existence could be in serious jeopardy. It seems destined to disappear forever in an unstoppable process. Discovered in 2008 around a star similar to our own Sun, it is a very hot Jupiter in the constellation of Kocher, between 800 and 1,500 light-years from our solar system. Introducing WASP-12b. Right from the outset, this exoplanet is far less attractive than its predecessor, isn't it? Its charcoal color, for a start, is more than atypical. In fact, one study suggested that it might be a rocky, carbonaceous planet, although the existence of this type of planetary object was still only speculative. Observations by the Spitzer telescope had excited astrophysicists, showing that it contained carbon atoms in strangely high quantities. Unfortunately, this feature turned out to be wrong, as the presence of another star, relatively close to WASP-12b, distorted the results. If this exoplanet ultimately has no more carbon atoms than any other hot Jupiter, how can we explain its dark asphalt-like appearance? New observations made with the Hubble telescope have shed light on this murky peculiarity. It turns out that WASP-12b absorbs over 94% of the light produced by its star. Hot Jupiters, on the other hand, reflect an average of 40%. Against all expectations, the researchers believe that it is the very high temperatures that provide a rational explanation. Heat in excess of 2,000 degrees Celsius, or 3,600 degrees Fahrenheit, causes the molecular hydrogen present in most of Jupiter's atmosphere to dissociate into atomic hydrogen. As a result, the upper layers of this exoplanet look more like a cold star, with, like it, an extremely high rate of absorption of visible light. In the last few minutes, you've probably noticed that this exoplanet is doing a macabre dance. Although almost twice the size of our own Jupiter, this gas giant orbits so close to its parent star in just 1.1 days that the consequences are already dire. You've probably noticed its strange shape, making it look like a rugby ball. That's because it's being angrily subjected to gravitational tidal forces to such an extent that it's being deformed. But beyond this deformation and the impact of the extreme heat thrown at it by this gigantic star, WASP-12b is literally being devoured. Scientists estimate that nearly 6 billion metric tons of its mass are going up in smoke every second. On the scale of the universe, you're witnessing the final moments of this exoplanet's inescapable grip. Gradually torn apart in its death spiral, this crackling gas giant will be totally consumed in 10 million years' time, unless it suffers a terrible explosion in the meantime. One way or another, its future is, unfortunately, already mapped out. But now let's turn our attention to a much more promising planetary system. Let's set course for the constellation Aquarius, where an ultra-cold red dwarf, TRAPPIST-1, reigns over not one, but 7 exoplanets. The idea of discovering any trace of life on just one of these planets would already be extraordinary. However, in February 2017, the discovery of this planetary system, at a distance of around 39 light-years from Earth, reinforced this hope. In fact, 7 rocky planets, almost the same size and mass as our Earth, orbit this star. Their orbits are all smaller than that of Mercury with our Sun. These planets are so close together that they sometimes seem to brush against each other. Such close proximity to the host star could be cataclysmic for these planetary objects. This is an M-type star, much cooler than our Sun, with an estimated mass of 9% of the Sun's mass. Of these 7 planets, 3 are located in the habitable zone and could harbor liquid water. These are TRAPPIST-1e, 1f, and 1g, the latter being the best place of all in this habitable zone. This system is therefore one of the most studied by scientists, especially as the proximity between these 7 planets could be conducive to potential panspermia. This means that life plants would be able to circulate from one planet to another via extraterrestrial contamination. As Chandra Wickramasinghe of Buckingham University explains, in such a planetary system, the exchange of bacteriological life is almost inevitable. But let's go inside this magnificent system and take a closer look at TRAPPIST-1F, the fifth planet, this promising super-Earth that seems to have turned its gaze toward its star. As you may have noticed, due to synchronous rotation, all planets invariably present the same face to their star. But unlike the other planets, TRAPPIST-1F is not completely covered by a thick mantle of ice or volcanic oceans. Locked in, like its companions, by the tidal forces emanating from the star, it would even have a strange physiognomy, strangely resembling an eye. Most of the planet, least exposed to the red dwarf's rays, would resemble a cracked mosaic. This cold, austere world, covered in ice and plunged into perpetual darkness, would have abundant water networks flowing through countless fissures. On the other hand, the part of the planet constantly exposed to the sun would be ice-free and might even contain an ocean, albeit in a vaporous state. Under these conditions, is it legitimate to hope to find any form of life there? Because of its distance from the sun, its average equilibrium surface temperature is minus 54 degrees Celsius or minus 65 degrees Fahrenheit. Could there be a ribbon of habitability between these two zones of extreme conditions? Could there be a termination line with temperatures conducive to the existence of liquid water? In the best-case scenario, is there enough atmosphere to even out these temperature mismatches and provide conditions conducive to the emergence of life? Observations of this system with the Hubble telescope have enabled us to measure the amount of ultraviolet radiation emitted by the star. These have a considerable influence on the evolution of planets, and consequently, on the presence or absence of water on them. The closest planets could have lost abysmal quantities of water, while TRAPPIST-1F and its two neighbors would have been much less impacted. Optimism, albeit measured, is the order of the day, allowing us to imagine that the appearance of life in these distant horizons could be envisaged. As you know, many civilizations have worshipped the sun. Imagine a planet where two suns shine brightly, giving you a double sunset. In fact, this fantastic vision is reminiscent of a scene from the famous Star Wars saga. Remember Tatooine, the birthplace of the famous Skywalker, where two suns light up the sky? But let's step out of fiction and join Kepler 16b, a planet also known as circumbinary, which actually exists. Discovered in 2011 using data gathered by the Hubble Space Telescope, its existence was detected using the radial velocity method. Located in the constellation Cygnus, 245 light-years from Earth, it has no astonishing features. It is a cold gas giant, comparable to Saturn in size and mass, with a radius around 75% that of Jupiter. This planet, a priori made up of as much gas as ice mixed with rock, has an equilibrium temperature of around minus 100 degrees Celsius or minus 148 degrees Fahrenheit. It orbits in just over 228 days, with a semi-major axis of around 104 million kilometers, or 64 million miles from the barycenter of its two host stars. But its singularity, as you may have guessed, is due to the fact that it orbits a binary star system. The two stars orbit each other in 41 days. The more massive star is an orange dwarf of spectral type K. The second, less massive and less luminous, is a red dwarf of spectral type M. Imagine what sunsets can be like on this planet, bathed in a more or less diffuse fog. The entire sky must be adorned in orange hues, giving the impression of an infinite celestial fire. For scientists, this discovery has confirmed the existence of circumbinary planets, and thus demonstrated the astonishing diversity of celestial bodies residing within our galaxy. But even stranger still, these two stars, in their cosmic dance, take turns masking each other, thus qualifying as an algol-type eclipsing binary star. Unlike binary systems composed of relatively similar stars, these two stars are very different from each other, the red dwarf being 3 times smaller and lighter than its neighbor, the orange dwarf. When the red dwarf passes in front of the orange dwarf, it partially eclipses the latter. Conversely, the more massive and voluminous orange dwarf completely obscures its companion. During this short time, a single sun seems to pour its rays onto the planet. Because of its composition, this duo doesn't really fit with the original definition of a binary star. According to the latter, a true double star results from the union of two stars formed together in the same system by the laws of gravitation. Be that as it may, this flamboyant duo offers a spectacular sight when placed in our line of sight, with the planet Kepler 16b in the foreground. However, this is not the most marvelous sight a planet can offer us. Still in the constellation Cygnus, in a slightly less distant region, just 150 light-years from our Sun, a planet whose discovery was announced in 2005 presents an even more spectacular panorama. Imagine contemplating the stars alongside this one and perceiving the last fiery rays of an immense sun about to disappear behind the horizon, while two other stars, modest in size and much warmer in hue, still illuminate the rocky peaks of a nearby lunar satellite. Isn't it a breathtaking sight? We're close to the hot planet HD 188753AB, which, as you'll have guessed, is part of a triple star system. Until 2005, the idea that a planet could form in a gravitational system as complex as that of a triple system was merely a hypothesis. The detection of HD 188753AB would have confirmed that planets can be far more resilient under extreme conditions than scientists had previously imagined. This hot, Jupiter-type exoplanet orbits in the vicinity of two stars that revolve around each other in 156 days, themselves revolving around a central star in just over 25 years at a distance of around 12.3 astronomical units. As a result, these three suns evolve in an area so small that our own solar system couldn't fit inside them. Indeed, their living quarters are no larger than the distance separating Saturn from our Sun. Scientists previously believed that hot Jupiters came to life in thick disks of material, far from their host star, before moving closer to it on the tides. HD 188753AB, a priori 14% more massive than Jupiter, would orbit the main star in just over 3 days, exactly 80 hours. 20 times closer to the main star than our Earth is to the Sun, this exoplanet would be only 8 million kilometers or 5 million miles away from the massive star. The reason I'm using the conditional tense to describe this exoplanet is that in reality, it has never been directly observed. Its presence has been suggested by measurements of the radial velocities of the triple system. Following the announcement of its detection by Polish astrophysicist Konaki, a European team of scientists claimed to have carried out the same measurements but failed to find it. For the time being, NASA has yet to confirm its actual presence, but who knows? Perhaps the existence of such a planet will soon be confirmed in this or any other system. After all, if its presence can't yet be truly confirmed, there's nothing to suggest otherwise. Let's continue our journey. I now propose that we reach a terrifying exoplanet which seems to harbor jewels that many would dream of possessing. Let's head for the constellation of Cancer, more precisely for the system of the star 55 Cancri, more commonly known as Copernicus. This double star, some 40 light-years from Earth, is composed of a yellow dwarf similar to our Sun and a red dwarf. Above all, 5 exoplanets orbit around them, including 55 Cancri e, discovered in 2004. Let's get closer to the latter while keeping a reasonable distance. Indeed, this planet orbits at a very short distance from Copernicus, its star similar to our Sun, from which it is only 2.24 million kilometers, or 1.5 million miles away. To give you a comparison, this represents approximately 20% of the average distance between Mercury and the Sun. As you can see, this planet's surface resembles a blazing inferno. Given its proximity to its host star, it's subjected to extremely high temperatures, hence its molten volcanic surface, completely covered in incandescent lava. Take a look at its many erupting volcanoes, spewing streams of lava across its surface. Clouds of steam and gas envelop this hellish planet, whose atmosphere is particularly turbulent and chaotic. 55 Cancri e seems straight out of a science fiction universe, with extreme conditions that defy our imagination. Its surface temperature is estimated at 2,500 degrees Celsius, or 4,500 degrees Fahrenheit, and its orbital year is incredibly short, at just 18 hours. And yet, this super-Earth is very real and of great interest to scientists, not least because of its unusual composition. With a radius estimated at twice that of the Earth and a mass around 8.6 times that of the Earth, 55 Cancri e has a very high density, suggesting that it could contain a significant metallic core. Indeed, its density of around 10.9 grams per cubic centimeter is close to that of lead. Given these exceptional characteristics, an international team of scientists came up with a mind-boggling hypothesis. In 2012, these researchers suggested that 55 Cancri e might be partly composed of diamonds. This idea, preposterous at first glance, stems from the fact that its host star, unlike our Sun, contains more carbon than oxygen. As a result, large quantities of iron, silicon carbide, and carbon, such as graphite and diamond, must have been present when 55 Cancri e was formed. Based on the mass of this super-Earth, scientists have estimated that a third of it, the equivalent of 3 Earth masses, could be composed of diamond. Imagine if we could cut open this planetary object. Beneath its crimson surface of molten graphite, a thick layer of glistening diamond would be revealed, like a river of diamonds in its dark velvet case. This extravagantly concealed shell would itself encompass a layer of silicon, including other minerals, and at its center, an inner core of molten iron. Unfortunately, this treasure remains inaccessible to ordinary mortals, both because of its remoteness and the impossibility of getting close to it. Too bad, isn't it? But before we burn our wings, let's leave this inferno and go to a far more pleasant world. This is Kepler 186f, an exoplanet located in the constellation Cygnus, some 500 light-years from Earth. As you can see, this planet is much more hospitable from the outset. Apart from its sandy beige hues, it looks very much like our beautiful blue planet. Beyond its appearance, it possesses many characteristics similar to our Earth, so much so that some consider it a potentially habitable exoplanet for human beings. Its discovery, confirmed in 2014, was made possible by the extensive data collected between 2009 and 2013 by NASA's Kepler Space Telescope. Kepler 186f is the first exoplanet to be discovered with a size almost identical to Earth, orbiting in the habitable zone of its host star at a distance of 52 million kilometers. Kepler 186, a red dwarf about 500 light-years from Earth, forms a planetary system of 5 planets. All are Earth-like in size, but Kepler 186f is the only one to be found in the habitable zone, its companions being far too close to their star. While there are many planets orbiting in the habitable zone, very few meet the essential criterion of being rocky. In fact, scientists usually discover low-density megaplanets composed mainly of gas, instead of gas giants. Kepler 186f, with a radius 1.1 times that of the Earth, is very likely to be a telluric planet. If a landing were possible, we would undoubtedly discover majestic mountain ranges and oceans separating various brown continents. The sun, half our size, would bathe us in daylight with its soft reddish rays without dazzling us. This constant mildness, due in particular to the absence of seasons, can be explained by the fact that the planet's rotation period is totally synchronized with its length of revolution, which is 130 days. Quite a nice environment, isn't it? But what is it really like? Does this planet have the necessary atmosphere to make it hospitable to our form of life? Observing this distant planet remains difficult for scientists, who for the time being can only speculate. However, their repeated simulations maintain the hope that an atmosphere compatible with liquid water is possible on Kepler 186f. What's more, the probability that it is indeed a rocky planet is sufficiently high. Could this be our second home? Before we left, I promised to surprise you throughout our journey. Now I'm offering you the chance to observe a planet straight out of the imagination of science fiction scriptwriters, a reverie that has since become reality. This is Gliese 1214b, an exoplanet sometimes nicknamed Waterworld, and with good reason. Discovered in 2009 in the Ophiuchus constellation, this is the first ocean planet to be completely covered in water. Its overall bluish hue is explained by its essentially aquatic composition. The light emanating from its host star, diffused through its dense atmosphere, is refracted by these infinite expanses of ocean, creating a soft, peaceful atmosphere. Detected by its 38-hour orbit around its host star, a red dwarf some 47 light-years from Earth, scientists were almost certain that it had an atmosphere. After studying this strange exoplanet more closely, using the James Webb Space Telescope in particular, they confirmed this hypothesis, and even concluded that it is dominated by water molecules. Unlike Neptune, this atmosphere is not made up of hydrogen and helium, but of heavy elements, in particular, water vapor particles. But this planet is even more atypical when we look at the distribution of its components. This is not a rocky planet on which sea levels have risen, as in Kevin Costner's feature film Waterworld. No, Gliese 1214b is 50% water, whereas our Earth's total mass is only 0.1%. This planet is therefore a new kind of planet, not related to either telluric or gaseous planets. This super-Earth has a diameter 2.7 times that of Earth, and a mass between 5.5 and 7.5 times greater. However, Gliese 1214b cannot support life as we know it, even if we consider only marine species. Its surface temperature is far too hot, reaching 200 degrees Celsius or 392 degrees Fahrenheit. What's more, its 200-kilometer or 125-mile thick atmospheric layer reinforces the greenhouse effect twice as much as on Earth. Finally, the enormous atmospheric pressure suffocates the planet. These extraordinary characteristics certainly shape water molecules, which agglomerate in the form of ice at high pressure. Although attractive at first glance, Gliese 1214b is a long way from offering visitors a warm welcome. But scientists don't despair. While the existence of these phantasmatic planets has been proven, researchers believe they are probably more common than previously thought. Indeed, among the thousands of planets detected of similar mass and size to this one, there could well be an ocean planet around every other star in the universe. But do you know the first exoplanet whose atmosphere was detected live by the Hubble Space Telescope? It's HD 209458b, nicknamed Osiris, an exoplanet that could almost be mistaken for a comet. Its discovery dates back to 1999, when it transited in front of its host star, a star similar to our Sun in the constellation of Pegasus, some 150 light-years from our solar system. Although Osiris could not be directly observed at the time, its presence was demonstrated by a change in the brightness of the star, HD 209458, occurring regularly every 3.5 days. Then, in 2007, the spectral lines of Osiris were observed directly using the Hubble Space Telescope. For the first time, the spectrum of an exoplanet could at last be precisely dissected. Thanks to an innovative process, NASA has declared that it is able to characterize the chemical composition of its atmosphere and consequently of many other extrasolar planets. But let's take a look at Osiris, a gas giant 200 times more massive than our Earth. With an orbit of just 3.5 days, it is evolving in close proximity to its star with disastrous consequences. Circling at speeds of over 500,000 kilometers per hour, or 310,000 miles per hour, it is subject to surface winds of up to 10,000 kilometers per hour, or 6,200 miles per hour. Barely 7 million kilometers, or 4 million miles from its star, 1/8 of the orbit separating Mercury from our Sun, its surface temperature exceeds 1,000 degrees Celsius, or 1,830 degrees Fahrenheit, on its immutably exposed face. These characteristics are at the origin of the plume it exhibits, like a comet releasing copious amounts of hydrogen. Osiris, this overheated gas giant, is living a veritable hell. Enveloped in a dense, hazy atmosphere with dominant hues of orange, red, and yellow, it's easy to make out the swirls of clouds that stretch across its surface and beyond. In this tumultuous, hellish landscape, it's easy to imagine the gigantic storms that reign here, punctuated by flashes of light, piercing this moribund atmosphere. The fact that this atmosphere includes free, even ionized oxygen and carbon atoms, right down to its outermost layers, has taken scientists by surprise. With a mass up to 10 times greater than that of hydrogen, how are they ejected from the deepest layers of the atmosphere? Hydrogen, the most abundant element in Osiris's atmosphere, is forcibly ejected by the star's heat and radiation in a stream strong enough to carry the heavier particles with it. According to astrophysicists, Osiris could be losing at least 10,000 tons of hydrogen gas every second. The planet has certainly already lost a significant part of its initial mass. Eventually, it may even be stripped of all its mass, leaving only a dense, inert crimson residue. This probable fatal outcome suggests to scientists the existence of a new planetary type. Is Osiris in the process of becoming a Chthonian planet? In other words, a rocky or metallic core of a gas giant planet whose atmosphere of helium and hydrogen has completely evaporated? This breathtaking spectacle is extremely intriguing, isn't it? In 2006, another planet was discovered with an orbit even shorter than that of Osiris. Dubbed the planet of eternal night by NASA, this is the darkest planet ever discovered orbiting a star. Meet TRES 2b, also known as Kepler 1b. This exoplanet, lurking in the Dragon constellation, 700 light-years from our Sun, looks like a coal ember on the verge of extinction. We won't attempt to enter its atmosphere, which is incapable of revealing anything other than total darkness. All the more so, as it is incredibly hot, with temperatures reaching 1,100 degrees Celsius or 2,000 degrees Fahrenheit. The gas giant's lava-hot atmosphere is due to its proximity to the G-type yellow dwarf star, which holds it in place by gravitational force. It turns out that this exoplanet is literally red-hot by its host star, from which it is only 5 million kilometers, or 3 million miles away. It takes just 2.5 days to complete a full orbit around its sun. Despite being bathed in the fiery rays of the yellow dwarf it orbits, this hot, Jupiter-like planet seems to absorb them almost entirely. Only a faint reddish glow emanates from this dark, mysterious object. With a mass of 1.49 Jovian masses, the planet's ability to reflect light is practically nil. To explain this peculiarity, scientists carried out new measurements using the Kepler satellite to calculate its geometric albedo, or reflection rate. This proved to be the lowest ever recorded, at less than 1%. Even a simple lump of coal would reflect more light. For the researchers behind this study, published in 2011, only the beginnings of an answer are conceivable. It is well known that hot Jupiter-type objects belonging to Class 4 of Zdarsky's classification must have a bond albedo of less than 3%. This is due, on the one hand, to the absence of reflective clouds in their atmosphere, the latter being the result of the condensation of volatile compounds such as ammonia. On the other hand, the presence of alkaline metals such as sodium and potassium vapors and gaseous titanium oxide has been detected. These are highly absorbent compounds. However, these characteristics solve only part of the TRES-2b enigma. The models we have carried out all indicate that its geometric albedo is 1 or even 2 orders of magnitude below the established theoretical value. For the time being, this dark monster doesn't seem willing to tell us more. Now let's discover a planet that strangely enough contains hot ice. You heard right, we're talking about a state of water particles that doesn't fit in with what you might have learned in your first physics lessons. We're used to saying that ice, when subjected to temperatures above 0 degrees Celsius or 32 degrees Fahrenheit, is supposed to melt and turn into water, or even evaporate at higher temperatures. It turns out that an exoplanet the size of Neptune, weighing around 22 Earth masses, could well be made up mainly of an exotic form of water. To observe it, let's go to the constellation Leo, 33 light-years from our Sun. Meet Gliese 436b. Its discovery, announced in 2004, was made thanks to the Hubble Space Telescope. This exoplanet is easily recognizable in this part of the cosmos, as it too has a comet tail. Its oxygen-rich hair is almost 50 times the size of the planet, a phenomenon never before observed on such a small exoplanet. Gliese 436b orbits just 4 million kilometers, or 2.5 million miles from a red dwarf, circling its host star in 2.6 days. Its highly elliptical and consequently eccentric orbit makes it all the more interesting for astronomers studying orbital dynamics and planet-star interactions. Nevertheless, invariably exposed to its heat, this hot, comet-like Neptune is constantly boiling. Scientists estimate that it loses around 1,000 tons of gas per second, and that over its 6 billion years of existence, it has lost 10% of its atmosphere. But the planet's strangest peculiarity lies in its bowels. According to planetary atmospheric models, any cosmic object containing a mixture of hydrogen, carbon, and oxygen, when subjected to temperatures of up to 726 degrees Celsius or 1,340 degrees Fahrenheit, should also contain a significant amount of methane and a lesser concentration of carbon monoxide. Thanks to data collected by NASA's Spitzer Space Telescope, we now know that this hot planet lacks methane, despite a temperature in excess of 526 degrees Celsius or 980 degrees Fahrenheit. Researchers believe that Gliese 436b is too compact to be composed mainly of hydrogen gas, as is Jupiter. but it's probably not compact enough to resemble a rocky super-Earth. For the time being, only one deduction has been suggested. Gliese 436b is thought to be mostly made up of an exotic form of water. This would be ice hardened not by a sufficiently low temperature, but by the incredible pressure of the outer layers undergone by the particles. Nestled between a hypothetical rocky core and its gaseous envelope of hydrogen and helium, an enormous ocean of water, compressed to the point of becoming as solid as ice, would be preserved in this planet. Gliese 436b thus offers a multitude of enigmas to solve and phenomena to study, all the more so as its proximity to Earth on a cosmic scale makes it a prime target. One of the strangest planets in our universe is still in the spotlight. Discovered in 2007, this extraterrestrial planet in the constellation Libra, just 20 light-years from our Sun, could well be the future destination of adventurers eager to explore a new habitable world. Make no mistake, the planet standing before you is not our beautiful planet Earth, although it does bear a striking resemblance to it. This is Gliese 581c, one of 6 planets orbiting a red dwarf, one of which, like Gliese 581d, lies within its habitability zone. With a mass 5 times that of our Earth, it has all the essential characteristics for the potential appearance of life. In particular, its close distance to the red dwarf, which is much cooler than our Sun, gives it a surface temperature estimated at between 0 and 40 degrees Celsius, 32 and 104 degrees Fahrenheit. Gliese 581c is therefore capable of sustaining oceans of liquid water, an essential constituent for the emergence of life. But there's a downside to this exceptional discovery. If you look closely, this planet, 11 million kilometers or 7 million miles from its star, completes its orbit in just 13 days. And this configuration is not without consequences. Gliese 581c rotates synchronously with its star due to the tidal effect, which is 400 times greater than the tidal force exerted by the Moon on our Earth. This means that the planet has 2 completely different opposing faces. One of them is perpetually turned towards its Sun, while the other always faces the interstellar immensity. As a result, one part of the planet is permanently exposed to the luminous irradiation of its red dwarf, never experiencing the lull of night, and even worse, burning brightly. On the other side, the cosmic cold transforms its surface into a thick icy mantle. And yet, between these 2 sides, which endure extremely antinomic conditions, a narrow strip forms a territory where life could well emerge, and why not already exist? And this idea is far from far-fetched. In 2008, a radio signal entitled "A Message from Earth" was sent from our planet in the direction of Gliese 581c. The signal is expected to reach this intriguing and promising blue planet around the year 2029. I leave it to you to imagine the amazement, infatuation, or fright this signal could provoke, should we receive a response in return in a few decades' time, or even a visit from extraterrestrials. This is reminiscent of the scenario in Battleship, a 2012 science fiction film in which aliens from Gliese 581c attack Earth after receiving one of our messages. In the end, lingering around this other blue planet might not be the best thing to do. You're probably wondering about it too. too much curiosity could well cut us off from a protective critical spirit. But let's leave this glittering land of welcome behind us. Illusory for the moment, it nevertheless holds out hope for the future discovery of a world equivalent to our Earth. All the more so, as the discoveries made in recent years have continued to shake us to our foundations. One of them concerns a gas giant discovered in 2009, whose properties continue to boggle the mind. Introducing WASP-17b, a hot Jupiter-like exoplanet whose dimensions at the time of its detection proved incredible. Located in the Scorpio constellation, over 1,300 light-years from the Sun, this gas giant orbits an F-type star. While its mass is almost 80% that of Jupiter, its radius is 1.5 to 2 times that of Jupiter, the largest planet in our solar system. For scientists, this discovery has once again broken the law concerning the sizes that can be reached by such an object in our universe. In theory, WASP-17b shouldn't exist. The unusual dimensions of this planet remain a mystery, unable to be explained by established models of planetary evolution. This gas giant is so swollen that its density, estimated at 0.17 grams per cubic centimeter, is only 13% that of Jupiter, or 70 times less than that of our planet Earth. By comparison, WASP-17b is less compact than a marshmallow with a density of 0.21 grams per cubic centimeter. As a result, this exoplanet is one of the lightest objects of its type ever discovered. What's more, with a radius of around 130,000 kilometers or 80,000 miles, this gigantic cosmic marshmallow completes a full rotation in just 3.7 days around its sun, only 7.7 million kilometers or 5 million miles away. But even more surprisingly, this planet behaves in a totally unexpected way, displaying a retrograde and a priori eccentric orbit. This means that it rotates in the opposite direction to its neighboring star. This configuration is probably at the origin of its unusually low density, as the planet is subject to strong tidal effects. Even more mind-boggling, data captured on March 12th and 13th, 2023 by the MIRI instrument on the James Webb Space Telescope, a cutting-edge piece of mid-infrared equipment, led to an unimaginable discovery. Researchers have announced the first ever detection of quartz nanocrystals in clouds in the upper atmosphere of WASP-17b. Silicates have already been detected in the atmospheres of other exoplanets. But this is the first time that a discovery of silicates composed solely of quartz has been detected in such an environment. This discovery was made possible by the planet's very short orbital period. This facilitated the study of transmission spectrography, a technique that measures how starlight is scattered and filtered as it passes through the atmosphere of an exoplanet. This exoplanet, with its increasingly incredible properties, has been the subject of another discovery, just as improbable as ever. Using high-resolution spectroscopy, a new team of scientists reported in August 2023 that they had detected another molecule in the atmosphere of WASP-17b. This is the first time that such a molecule, usually detected in stars, has been found in a planetary atmosphere. The molecule in question is chromium hydride, a metallic chemical compound nicknamed the thermometer molecule. This extremely rare metal hydride is singularly abundant in a temperature range between 930 and 1730 degrees Celsius, or 1700 and 3150 degrees Fahrenheit. Through these discoveries, scientists hope to gain further insight into the formation and evolution of this planet, but also of others. Now that they know that such molecules can be found in the atmospheres of similar objects, they will be able to focus their research even more precisely. It's a valuable opportunity for them to deepen their understanding of exoplanets and the processes that govern their atmosphere, formation, and evolution. Let's move on to another Jupiter-like gas giant and find out why this one intrigues astrophysicists so much. Named HD 106906b, this exoplanet, 11 times more massive than Jupiter, was detected around 336 light-years from our Sun in the Southern Cross constellation. This exoplanet stands out for its very strange orbital properties, and with good reason. It takes almost 15,000 years to complete one revolution around its host star, a pair of stars made up of two F-type yellow-white dwarfs. When its discovery was announced in 2013, scientists declared it a great first. No other planet has ever been detected so far from its central star, its distance having been estimated at over 730 astronomical units, or practically 68 billion kilometers, or 42 billion miles. To calculate this orbit, astronomers were able to draw on 14 years of data collected by the Hubble Space Telescope. This extraordinarily precise data enabled scientists to prove the unusual motion of a gas giant. It moves with unprecedented slowness due to the weak gravitational attraction between it and its host stars. Even more surprising, this exoplanet follows a relatively elongated orbit, but more importantly is located outside the debris disks surrounding its parent star, unlike most exosolar planets of the same type. What's more, this disk appears to be undergoing significant gravitational interactions, and is also showing itself in a particularly unusual shape, not circular, but stretched and asymmetrical. The question now is how such a planet could have ended up so far from its main star, and what's more, outside the disk. Astrophysicists initially suggested that the planet had indeed formed inside the debris disk, but that the strong gravitational interactions had then ejected it into interstellar space. A nearby star would in turn have allowed this gas giant to stabilize its atypical orbit, preventing it from drifting forever into the cosmos. However, this theory has been called into question by other researchers who have developed a model to track the orbital trajectory of HD 106906b, and above all, to determine its impact on the debris disk. While no other planets have been detected in this planetary system, the orbit of the one studied alone is sufficient to explain the shape of the disk. What's more, this new study calls into question where this exoplanet formed. According to the scientists, the model shows that it probably formed not inside, but outside the disk. If this were not the case, and still according to their model, the shape of the disk would be very different from what we can observe today. Still, the enigma remains unsolved. Could it be that neighboring stars have destabilized the planet during their migration, causing the planet in turn to disrupt the disk? Conversely, could the host stars of this binary system have caused disturbances to the planet, subsequently distorting the disk? Or could neighboring stars during a close passage have simultaneously disturbed the planet and the disk? I'd now like to take you to the constellation of Centauri, where you'll be in for another surprise. Located 430 light-years from Earth, an orange-colored star in the pre-main sequence, whose mass and size are similar to those of the Sun, has a most extravagant planet as its companion. Meet J1407b and its celestial jewels, spread out like no other in this starry cosmos, discovered in 2012. As you can see, it boasts dozens of rings, whose impressive size is enough to make our beautiful Saturn swoon, their diameter reaching 120 million kilometers, or 75 million miles. In comparison, Saturn's rings are 200 times larger, equivalent to the surface of several full moons in our night sky. According to astronomers, there appear to be more than 30 of them, each harboring innumerable grains of cosmic dust, and perhaps even good-sized lumps of matter. Once again, this astonishing discovery was made by chance. During an exoplanet search program, the star of this planetary system attracted attention for its behavior. During nearly 2 months of observation, its light curve showed particularly anarchic and rapid fluctuations, ranging from a few tens of minutes to several hours. Faced with this phenomenon, only one explanation emerged. The star is eclipsed by a system of rings, the latter displaying a wide range of dimensions. What kind of exoplanet could possibly have such attributes? It's probably a super Saturn in its infancy. The rings contain a lot of matter in the form of dust, which is likely to gradually coalesce into satellites orbiting the planet. In fact, one of these hypothetical satellites is probably in the process of forming, as evidenced by the existence of a gap within this enormous structure. This apparent gap between two disks can plausibly be explained by the formation of a satellite in this portion, which has agglomerated most of the matter present here. According to their estimates, this exoloon could have a mass somewhere between that of the Earth and Mars, and would take 2 years to complete a full revolution around J1407b. For astrophysicists, this process is only just beginning. In several million years' time, after having thinned considerably, these rings will eventually disappear forever, leaving in their place several satellites orbiting this super Saturn. But for now, we can still enjoy the grandiose spectacle offered by these gigantic rings. Our journey now takes us close to an exoplanet that seems to rival most stars. We'll take a step back, as its temperatures are extremely hot. In fact, it's hotter than at least 80% of the stars in our universe. Back in the Cygnus constellation, 650 light-years from Earth, here's Kelt 9b. Discovered in 2017, this strange planet with an atmosphere unlike any other is the hottest ever detected. An ultra-hot Jupiter, it orbits its star, itself known for its more than strange properties. Almost twice the size of the Sun, this star is also one of the hottest known to date. You're looking at one of the most extraordinary duos in the universe. This host star reaches insane temperatures, approaching 9,900 degrees Celsius or 18,000 degrees Fahrenheit. As a reminder, our Sun, whose fiery rays are already enough to wreak havoc, doesn't exceed 5,500 degrees Celsius or 10,000 degrees Fahrenheit in surface temperature. But that's not all. This blue giant star rotates so fast that its appearance is distorted, with flattened poles in a singularly enlarged equatorial zone. In fact, its flattened spheroidal shape has repercussions for its companion planet. Although Kelt 9b experiences unprecedented temperatures, being some 30 times closer to its star than the Earth is to the Sun, it does have seasons. Take a look at this magnificent gas giant. Almost twice as large as Jupiter, its mass is estimated at almost 3 Jovian masses. Exceptionally close to its host star, it receives 44,000 times more energy than we do from the Sun. As you can see, this colossal exoplanet orbits rapidly. Its complete revolution takes just 36 hours. Rather short for a year, isn't it? Its orbit follows a trajectory that passes just above the star's 2 poles. So when Kelt 9b is near one of them, it passes through an extremely hot zone. But when it faces the star's swollen equator, it benefits from a certain cooling. This strange planet thus experiences 2 warm seasons and 2 winter seasons, so to speak, at regular intervals every 36 hours. On the other hand, due to its proximity to the star, the planet is locked onto the latter's gravitational tides, immutably showing the same face to this blazing sun. If Kelt 9b hadn't been so massive, its atmosphere would have evaporated long ago under the effect of the ultraviolet radiation produced by the star. Like Mercury, it would already resemble a small rocky desert core. Nevertheless, this scenario could well unfold at any moment. For the time being, however, its vaporous envelope is undergoing the wrath of this unusual star. Kelt 9b's atmosphere is continuously plowed by its parent star, to the point where it resembles no other planetary atmosphere, as attested by a study published in 2018 in the journal Nature. The abundant hydrogen molecules are literally torn apart when exposed to the star's fierce forces. Then, when they reach the planet's dark side, they recompose. Then, when they again come into contact with the star's light, the process starts all over again. Analysis of this atmosphere has also enabled scientists to detect iron and titanium atoms, which cannot combine with other atoms due to the intense heat. Kelt 9b is therefore one of the first planets to detect iron in its atomic form. Iron, though abundant in the universe, is usually combined with other molecules when identified in the vicinity of any solid cosmic form. Once again, this atypical planet is a formidable field of exploration for astrophysicists. Future observations will enable us to study in greater detail the boundary that separates the 2 sides of this exoplanet. And who knows, could water molecules be present? When we think of luminous objects in the night sky, we usually think of the many stars. However, all kinds of celestial bodies are also capable of shining. Such is the case of an exoplanet discovered in 2020 by NASA's TESS satellite. This is LTT 9779b, the brightest exoplanet ever detected by astronomers outside our solar system, with a brilliance similar to that of Venus. Located more than 260 years from our Sun in the constellation of the Sculptor, this exoplanet is of the hot Neptune type. Its radius is around 5 times that of the Earth, while its mass is 29 times greater. With an orbital period of just 17 hours, it is one of the few planets recorded in the hot Neptune desert. Given its proximity to its host star, it's no surprise that scientists have recorded extremely high surface temperatures, reaching over 2,000 degrees Celsius or 3,600 degrees Fahrenheit on its illuminated side. Astrophysicists have estimated that this strange planet is able to reflect 80% of the light emitted by its host star. But how is this planet able to behave like a reflecting mirror, and precisely in this configuration? Because of the extreme heat, no clouds are expected to form on the surface of such an object. And yet, it would seem that clouds are the reason LTT 9779b looks the way it does. Until now, only gas giants 10 times larger than our Earth, or modest rocky planets half their size, have been detected with orbits of less than 24 hours. But this exoplanet is about 5 times the size of our Earth. Its existence alone is already a mystery. What's more, given its proximity to its host star, any trace of atmosphere seems unthinkable. The latter should have been torn off long ago. For scientists, there is only one possible explanation. The planet's atmosphere is saturated with silicate vapors, the material found in glass, and metal vapors vaporized by the intense heat. In short, metallic clouds envelop the planet. Like a shield, they are incredibly reflective, giving it an extraordinary mirror-like appearance and preserving its atmosphere. The detection of such a planet represents a major breakthrough for the scientific community. In particular, it provides proof that an object the size of Neptune can survive in such an unseemly environment. But what happens when the star of a planetary system dies? What happens to the planets as their host star declines to the white dwarf stage? While the inner planets are probably absorbed during the red giant phase, do the outer gas giant planets manage to survive? This question is far from trivial, for what will become of our own planetary system when our sun reaches this stage? A team of astronomers recently found the answer. After pointing the sensors of the James Webb Space Telescope at various white dwarfs, the scientists succeeded in detecting 2 massive exoplanets. Each of these 2 planets orbits a dead star, both at distances similar to those of the gas giants in our solar system. These 2 exoplanets, named WD 1202-232 and WD 2105-82, have masses estimated at 1 and 7 times that of Jupiter. Respectively, 5.3 and 1.6 billion years old, these gas giants orbit at 11.5 AU for the former and 34.6 AU for the latter. This configuration is ideal for scientists. The 2 exoplanets bear a striking resemblance to Jupiter and Saturn respectively. What's more, our sun in a few billion years' time should resemble this white dwarf. Better than divination, this discovery is capable of showing us what our own system will probably look like when the time comes for our sun to slumber for eternity. Before turning into a white dwarf, our star will most likely annihilate the planets in its inner system, including our beautiful Earth. On the other hand, gas giants like these two exoplanets are likely to survive the cosmic upheaval. Our journey is coming to an end. We're about to return to terra firma, topped by a more forgiving sky where the weather, though sometimes capricious and devastating, remains most clement. Through the worlds we've just visited, each more fascinating and intriguing than the last, you've been able to observe the diversity and richness of the universe that surrounds us. While the cosmos abounds in systems with extraordinary properties, few are thoughtful enough to support any form of life. However, one recently discovered exoplanet, located just 137 light-years away, is proving to be very promising. This is the exoplanet TOI 715b, whose discovery was announced in January 2024 by NASA. This super-Earth evolves in the so-called conservative habitable zone around its star, a red dwarf, alongside a second, even larger planet, whose existence has yet to be confirmed. While the presence of liquid water on its surface is conceivable, thanks to ideal temperatures, the other criteria essential for life are still being studied. This exoplanet, which receives the equivalent of 86% of the light we receive from the Sun, could well be covered with oceans and continents. Clouds similar to our own are also conceivable. Of course, no one can say whether it is actually habitable, or whether it already harbors even a single form of life. But this possibility is a beacon of hope, driving researchers ever onward to explore the cosmos. Who knows what the future holds? Perhaps one day we'll be able to make contact with other civilizations from an unknown world. And why not finally tread the soil of extraordinary exoplanets? Before we begin on our journey to the mysterious moons of our solar system, let's take a look at what we call moons. Moons are celestial objects that orbit a planet like satellites. There are over 200 known moons in our solar system. To date, NASA has counted exactly 214. The Earth has only one moon. With the exception of Mercury and Venus, all the planets in our solar system have several moons. Even dwarf planets like Pluto and many of the asteroids in our solar system have moons. Let's take a look at the planets in our solar system. Our neighbor Mars has two moons, Phobos and Deimos. These two moons are small bodies orbiting a few thousand kilometers from the red planet. Subject to the tidal forces of Mars, they rotate synchronously, meaning they always face the same direction as the planet. Their orbits evolve over time. Phobos moves closer to Mars, while Deimos moves further away. Let's continue moving through the solar system away from Earth. Neighboring Mars, the gas giant Jupiter is the planet with the most moons, with 92 confirmed satellites. Io, Europa, Ganymede, and Callisto, Jupiter's four largest satellites, are called Galilean satellites as they were discovered by Galileo in 1610. In fact, they were the first moons to be discovered after our own. Saturn is the second planet with the most moons, with 144 confirmed satellites, of which 66 have been given official numbers and 63 their own names. Saturn's two best-known moons are Enceladus and Titan, which we'll explore later in this trip. After Saturn comes the planet Uranus. 4 times larger than the Earth, it is the 3rd largest planet in the solar system after Saturn. Along with Neptune, it is one of the 2 icy planets in our solar system. Uranus has 27 moons. The first 2 satellites of Uranus to be discovered, in 1787, Titania and Oberon, take their names from Shakespeare's play. Titania is the largest satellite of Uranus and the 8th largest in the solar system. Neptune has 14 confirmed satellites, the largest and first to be discovered in 1846 being Triton. Pluto, demoted to dwarf planet status in 2006, is part of a double system with Charon, one of its satellites. Pluto's 4 other satellites are Styx, Nix, Kerberos, and Hydra. Let's turn first to Jupiter, the largest planet in our solar system, but also the one with the most moons. Jupiter is the 5th planet in the solar system in order of distance from the Sun, from which it is 779 million kilometers, or 485 million miles on average. This gas giant is the largest planet in size and mass, ahead of its neighbor Saturn. Its average radius is 69,911 kilometers, or 43,500 miles, or 11 times that of the Earth, and its mass is 318 times that of our planet. In fact, Jupiter is so huge that it has been visible to the naked eye since prehistoric times. After the Sun, Moon, and Venus, Jupiter is the 4th brightest object in our night sky. In fact, its great luminosity is the origin of its name, which comes from the Roman god Jupiter, master of the other gods. Composed mainly of hydrogen and helium, Jupiter's composition is similar to that of the Sun. Although it has a rocky core of heavy elements, it has no solid surface. In its atmosphere, several elements have been detected, including methane, ammonia, sulfur and nitrogen compounds, and water ice. Jupiter, its 92 moons and rings, are known as the Jovian system. But the giant planet's influence extends far beyond the Jovian system. This influence is exerted, for example, on Jupiter's Trojan asteroids, a group of asteroids that share its orbit around the Sun. The first space probe to fly over Jupiter was the American Pioneer 10 in 1973. Until 1979, the planet was explored by Pioneer and Voyager 1 probes. Then between 1995 and 2003, the Galileo probe orbited Jupiter, followed by the Juno orbiter in 2016. Juno is currently still orbiting Jupiter, until at least 2025. Unfortunately, we've long known that the chances of Jupiter harboring life are remote. Not only does Jupiter have no solid surface, but its presence and internal temperatures are extreme. No biological object could survive on this type of planet. So why do Jupiter exploration programs continue to fuel the hopes of alien hunters? Because Jupiter has 92 moons, 4 of which could potentially be habitable. These are the famous Galilean moons. That Jupiter's moons are habitable is hardly surprising. The Jovian system is often compared to a miniature version of the solar system. Jupiter accumulated so much thermal energy due to gravitational contraction during its formation that it now releases more thermal energy than it receives from the Sun. It could therefore act for its moons like the Sun for the planets in our solar system. Jupiter's 4 Galilean moons were discovered by Galileo in 1610. The Italian astronomer gave his name to these satellites, although they may have been observed earlier by the Chinese astronomer Gan Day in 362 BC. Between the end of the 19th century and the early 1650s, 8 other satellites of Jupiter were discovered: Amalthea, Himalaya, Elara, Pasiphae, Sinope, Lysithea, Carme, and Anakie. Leda and Themisto were discovered in the 1970s. So, before the arrival of space probes on Jupiter, 14 satellites of the Jovian system were already known. In 1979, 3 more moons were discovered. The number of known satellites was increased to 63 by new observations at the turn of the century, and from 2010 onwards, new observations expanded the catalog of Jovian moons. The last 15 known satellites were discovered very recently, in 2022 and 2023. So it's possible that more will be found in the years to come. It's true that at first glance, Jupiter's moons don't seem very hospitable. They are far from the Sun, almost all encased in ice, and their atmosphere is very sparse. But their observation has revealed some fascinating facts that are well worth investigating. Galilean moons are likely to conceal liquid oceans beneath their icy crusts, and liquid water means the development of biological organisms. What's more, the thick ice crust could provide good protection against radiation and meteorites, as well as thermal insulation conducive to the development of life, a bit like our atmosphere on Earth. But let's take a closer look at these moons to find out more about their potential for harboring life. Fasten your seatbelts as we explore Jupiter's 4 Galilean moons: Io, Europa, Ganymede, and Callisto. Let's start with Io, perhaps the moon in the Jovian system least likely to harbor extraterrestrial life. You'll soon see why. Io is also called Jupiter 1, perhaps because it is the satellite of Jupiter whose orbit is closest to the gas giant. Its period of revolution is just 42 hours. It is Jupiter's 3rd largest moon and the 4th largest in the solar system. But it's also the densest and most geologically active, with over 400 active volcanoes. The fact that Io is so volcanically active first surprised scientists. When the Voyager probe flew over Io, it detected something unexpected on its surface: hundreds of giant active volcanoes. Other probes have since spotted huge lakes of molten lava. These discoveries are quite astonishing, as volcanic activity on Earth is fueled by the heat of the Earth's core. However, Io is so small that it must have cooled down completely billions of years ago. The only possible explanation was that Io certainly conceals in its core another source of energy that can continuously fuel this volcanic activity. The observation of volcanoes on Earth and the data collected on Io enabled us to imagine what life would be like on this moon. Living on Io would mean living in an extremely hostile environment, very cold or very hot, with no atmosphere. If you were to walk on Io, you would bounce slightly because the gravity on Io is the same as on the moon, 6 times less than on Earth. You could walk through black lava fields and witness phenomenal volcanic eruptions. Because on Io, eruptions are extremely spectacular. The gases released by the lava project clouds into the interstellar void. On its way to Pluto, NASA's New Horizons probe passed close to Jupiter in March 2007 and photographed an impressive volcanic eruption on Io. The eruption was that of the Tvashter volcano. The images taken at the time by the probe's high-resolution telescopic camera are impressive. They show a plume over 300 kilometers, or 185 miles high, rising in Io's northern hemisphere, and then raining down on the surface. These images provide researchers with proof that volcanic eruptions on Io are violent and powerful. But what could be generating so much energy in the heart of this frozen moon? In fact, this intense geological activity is the result of tidal heating. This heating is due to the friction generated inside the moon by its gravitational interactions with Jupiter and 2 other Galilean satellites, Europa and Ganymede, with which it is in orbital resonance. In other words, with each of its revolutions in its elliptical orbit around Jupiter, Io is buffeted by the gas giant's gravitational forces. When it reaches the point in its orbit closest to Jupiter, it undergoes a deformation of over 100 meters or 330 feet. Imagine this over billions of years, and you can see how intense friction could have arisen within this small moon. It's a bit like twisting and unfolding a piece of metal. It will eventually heat up. It's the same for Io. These movements and deformations have created an alternative energy source at the heart of Io, capable, in theory, of promoting life. Remember, life needs 3 elements to emerge, including a source of energy. With these discoveries, researchers realized that they had to stop believing that habitable celestial objects had to resemble the Earth in every way, and that habitable zones were necessarily dependent on the Sun. The perimeter likely to harbor life extended from the Earth to the farthest reaches of the solar system. However, the probability of life existing on Io remains very low. Yes, Io has an energy source. Yes, Io could contain the chemical elements that make up life, which would have been disseminated like on Earth by comets and asteroids billions of years ago. But researchers have never succeeded in finding the 3rd element necessary for the emergence of life: liquid water or its equivalent. Why couldn't there be liquid water under Io's volcanic crust? Because, unlike other moons, Io is not made of water ice, but of silicate rock, surrounding a molten iron or pyrite core. Although the chances of Io harboring any form of life are slim to none, researchers are nonetheless interested in this moon for its intense volcanic activity. The interest of these volcanoes is not only scientific, but also aesthetic, as the images of this moon are magnificent. Io's volcanoes produce plumes of sulfur and sulfur dioxide, which, after rising several hundred meters, rain down and cover the moon's vast plains with a frosty layer of material. This material also forms a thin layer of atmosphere. Lava flows can extend over 500 kilometers or 310 miles in length. The moon's surface is constantly changing, taking on shades of yellow, red, green, white, and black. Io's surface is also dotted with over 100 mountains, the result of tectonic phenomena on the moon's silicate crust. Some of these mountains rise very high, even higher than Mount Everest, even though Io's radius is 3.5 times smaller than Earth's. Impressive, isn't it? There's no doubt that researchers won't be giving up their observations of this moon, which still conceals so many mysteries other than that of life. Let's continue our exploration of the Galilean moons with Europa, or Jupiter 2, the sixth closest moon to Jupiter. Europa has a period of revolution of 85 hours. With a diameter of 3,122 kilometers, or 1,900 miles, it's the smallest of the Galilean moons, but the sixth largest in our solar system. It's also the most interesting in the search for extraterrestrial life. In fact, according to researchers, it's the one where life is most likely to be found. Let's take a closer look at this mysterious moon. Europa has been flown over 12 times by NASA's unmanned spacecraft Galileo. Virtually all our data on Europa was collected by this probe. Europa is barely smaller than our moon. It consists mainly of silicate rock, with a crust of water ice and a core, probably of iron and nickel. It has a very thin atmosphere composed mainly of oxygen. Its temperature at the equator is minus 183 degrees Celsius or minus 297 degrees Fahrenheit, and its temperature at the poles can drop to minus 223 degrees Celsius or minus 370 degrees Fahrenheit. Unlike Io or our moon, its surface is free of craters, making Europa the smoothest surface celestial object in the solar system. Its surface is relatively young, estimated to be just 100 million years old. Locked in by Jupiter's tides, Europa rotates synchronously around the gas giant, so it always presents the same face. Small deviations in its rotation have been observed. All these observations could mean that there is a liquid layer between the surprisingly smooth surface of this small moon and its rocky core. This hypothesis was confirmed by the Galileo probe studies of the satellite's interaction with Jupiter's magnetic field. While there are no impact craters on Europa's surface, there are glacial striations and fissures known as lineae. These crevices have been analyzed by the Galileo probe. The analyses show that in the past, the satellite's crust moved 80 degrees in relation to its interior, which would have been impossible without a liquid layer beneath the surface. What's more, as the Galileo probe got closer to Europa, it was able to observe these cracks more closely. The data collected suggests that in some places the ice cracked, then a trench formed, and a material filled the empty cracks and froze, allowing the parts to be welded back together. It's a bit like kintsugi. The probe also showed huge fields of jagged ice, as if the ice had melted and then roughly reconstituted itself, reminiscent of the ice that covers our oceans on Earth. The Galileo probe also took measurements of Europa's magnetic field. Analyses revealed the presence of an electric current that could correspond to that of a salty ocean of liquid water. According to the prevailing model, Europa's slightly eccentric orbit, maintained by its orbital resonance with Io and Ganymede, causes a tidal heating effect, allowing the ocean to remain liquid. This leads to a movement of ice, similar to plate tectonics, the first time this mechanism has been found anywhere other than on Earth. Like Io, Europa is therefore heated by internal friction due to its interaction with the gravitational fields of Jupiter and the satellites with which it is in orbital resonance. This may explain the jagged ice, which appears to have been melted and then refrozen. These interactions would cause powerful tidal waves in its inner ocean, further raising the temperatures inside the satellite. All this makes the presence of a liquid ocean possible. According to the researchers, this internal ocean could be as deep as 100 kilometers or 60 miles, with a volume twice that of our oceans on Earth, nicknamed the Blue Planet. Europa thus appears very different from its sister moon Io. It is covered by an exceptionally smooth and clean layer of ice. The highest features of its relief rise only a few hundred meters above the surface, a completely different landscape from Io's high mountains. The thickness of the ice crust varies between 10 and 30 kilometers, or 20 miles. Europa's surface is striated by a network of long, deep fissures. Some of these cracks may be reaching the groundwater layer. If this is the case, the ice that covers the bottom of the crevices provides valuable material for studying Europa's interior composition. Europa's geysers occur regularly throughout the moon's orbit, but are most frequent when the moon is furthest from Jupiter. This is because Jupiter's tidal forces are weaker when the moon is further away. These tidal forces are responsible for the formation of geysers, forcing water from the underground ocean towards the surface. These geysers, detected by the Hubble telescope, can reach up to 200 kilometers or 125 miles in height. These giant jets are made up of water vapor, a surprisingly clean form of water. It's possible that this water comes from Europa's underground ocean, or from giant lakes hidden beneath the ice crust. These are invaluable to scientists, as they would enable them to detect traces of life without having to use a lander. For the moment, nothing is certain. In the absence of concrete data, the composition of Europa's ice crust is currently estimated on the basis of one of its largest craters. Spectral analysis of the craters reveals compounds of magnesium, sulfur, iron, and hydrogen peroxide. Conclusion: there is certainly a wide diversity of minerals in the satellite's hidden hydrosphere. It's also important to point out that Europa's atmosphere contains oxygen, which is formed when icy water is broken down by UV rays. But Europa's gaseous envelope remains 1 trillion times sparser than that of the Earth. In any case, according to some calculations, the oxygen concentration in Europa's oceans could be sufficient to sustain single-cell aerobic life. Aerobicity is the ability of an organism or microorganism to thrive in ambient air using oxygen. Europa has liquid water and the building blocks of life. We still need a third element to affirm that life can develop there, a source of energy. And it does have a source of energy, undersea volcanoes that saturate the water with sulfur and iron oxides. Some researchers even claim that there could be multicellular organisms in the European Ocean, but this hypothesis is still premature. In any case, all we know is that we can't rule out the possibility of primitive life on this mysterious moon of Jupiter. Faced with all these possibilities, researchers are wondering whether it is really possible for a form of life to survive in this type of environment, namely, a cold liquid ocean enclosed beneath kilometers of ice, with no access to the sun's energy and with underwater volcanic activity as its sole source of power. The answer could lie on Earth. Biologist Tim Schenck has explored the waters of our planet that bear the closest resemblance to the icy depths of the Jovian satellite. 320 kilometers or 200 miles from the North Pole, the biologists sent robots 3,600 meters or 12,000 feet deep beneath the Arctic ice sheet, where sunlight never breaks through. In other words, the robots were sent into an ultra-hostile environment where temperature and pressure levels are extreme due to underwater volcanic activity. The aim? To understand what might be going on beneath Europa's ocean by observing the most hostile underwater environments on our planet. At depths of 3,600 meters or 12,000 feet in the heart of the Arctic Ocean, Tim Schenck's robots, unsurprisingly, collected evidence of a very hostile environment. Volcanic fissures spew water at 370 degrees Celsius or 698 degrees Fahrenheit, saturated with toxic chemical compounds such as hydrogen sulfide. This type of fissure is more than likely to be found in the depths of Europa's oceans. Surprising as it may seem, Tim Schenck has discovered living organisms around these cracks. These cracks are in fact lined with microbes for miles around, new forms of life that we never knew existed, but which are indeed living organisms. Even the polar oceans on Earth harbor microbial life, so why not on Europa? How do these microbes survive in such a hostile environment? Instead of using the sun's energy, they use sulfur, methane, and hydrogen as a source of chemical energy. The next step is to land a probe on Europa to verify the scientists' theories. But for that, we'll have to wait a little longer. For one thing, the moon is 628 million kilometers away. What's more, we'd have to build a robot capable of crossing kilometers of ice, then swimming in the icy water to collect data. This is already a complex task on Earth, so imagine it over 600 million kilometers from our planet. Are moons that generate heat as they make their revolution, causing the ice to melt and underground oceans to form, ideal for the development of life? A far-fetched idea? Perhaps not, as Europa is not the only moon that could fit this model. Ganymede, or Jupiter 3, is the third Galilean satellite. Its orbit lasts about 7 Earth days. It is not only Jupiter's largest satellite, but also the largest in the entire solar system. In fact, it's the satellite that most closely resembles a planet. Its diameter, is 5,268 kilometers, or 3,000 miles, or 8% larger than the planet Mercury and 2% larger than Saturn's largest moon, Titan, which we'll study later. However, its mass is only 45% that of Mercury, as it is made up of equal amounts of water ice and silicate rocks, whereas Mercury is made up solely of rocks and metals. Ganymede is just over twice the size of our moon and twice as heavy as our satellite. You can see it with the naked eye in our night sky. It's the only satellite in our solar system with a liquid metal core and its own magnetosphere. This magnetosphere was probably created by convection within the liquid iron core. Ganymede completes its orbit around Jupiter in 7 Earth days, around 1 million kilometers from the gas giant. Its orbit is slightly eccentric and inclined to Jupiter's equatorial plane. Its rotation is controlled by Jupiter's gravitational tidal effects, like Io and Europa, so it too is in synchronous rotation. When Ganymede makes 1 complete revolution around Jupiter, Europa makes 2 and Io 4. Ganymede is therefore in orbital resonance with the other 2 Galilean moons. Ganymede's atmosphere is thin and contains several elements: atomic oxygen, dioxygen, and possibly ozone, as well as atomic hydrogen in small proportions. Pioneer 10 was the first probe to take a close look at Ganymede. In the 1970s, the American probes Pioneer 10, Pioneer 11, and Voyager 1 and 2 provided some insight into Ganymede. Then, the Galileo probe refined some of the data we have on this Jovian satellite, thanks to 6 close flybys between 1996 and 2000. Thanks to Galileo's data, we were able to discover its underground ocean and magnetic field. Like Europa, Ganymede is thought to have an ocean under its surface ice, which could contain more water than all the oceans on our planet put together. 1/3 of the satellite's surface is covered by 4-billion-year-old impact craters, and 2/3 by lighter-colored regions cut by wide grooves. This relief is probably the result of tectonic activity, triggered by tidal heating, although for the moment it remains a mystery to scientists. Some researchers believe that Ganymede has an ocean sandwiched between 2 layers of ice, while others think that there are several layers of ocean separated by different layers of ice, a bit like a mill fuel of water and ice. Ganymede's magnetic field is due to its iron-rich liquid core. As the magnetosphere is essential to protect us from radiation coming from space, the existence of this magnetic field is an argument in favor of the presence of life on this moon. Ganymede's magnetic field produces polar auroras, as shown by images taken by the Hubble telescope in 1995. Another feature of this magnetic field is that it is contained within the larger magnetic field of Jupiter. Studies of Ganymede's magnetic field by the Galileo probe show that there could be a multi-layered salty ocean beneath the ice crust at a depth of at least 200 kilometers or 125 miles. Multi-layered because this ocean could have up to 4 layers, each with its own salinity and density. These 4 layers would be separated by ice. On the surface of Ganymede, Galileo's high-resolution spectroscope has revealed the presence of a large number of non-aqueous materials. These include carbon dioxide, sulfur dioxide, sulfuric acid, various organic compounds, magnesium sulfate, and sodium sulfate. These materials probably originate from Ganymede's subglacial ocean, although it is not yet known by what mechanisms these compounds could have reached the surface by penetrating the satellite's crust. Researchers believe that Ganymede may have formed by accretion, i.e., the progressive agglomeration of the gases and dust that surrounded Jupiter after its formation. The average surface temperature of Ganymede is minus 148 degrees Celsius or minus 234 degrees Fahrenheit. A decay process inside Ganymede would heat the satellite even more, so that the core would have an average temperature of 1200 to 1400 degrees Celsius or 2550 degrees Fahrenheit. The presence of oxygen in Ganymede's atmosphere is not in itself proof of the presence of life on this satellite, as molecular oxygen can result from the decomposition of water ice under UV light. During this process, hydrogen evaporates into space, and oxygen, a heavier element, is deposited on the surface. For the moment, nothing is certain, but Ganymede remains a moon to keep a close eye on in the quest for extraterrestrial life in our solar system. We're now going to explore Jupiter's last Galilean moon, Callisto. Callisto, or Jupiter 4, is the second largest Jovian moon after Ganymede and the third largest in the solar system. It is the Galilean moon furthest from Jupiter, and therefore the only one of the four not to be in orbital resonance. Like Ganymede, Callisto is thought to have formed by accretion from the disk of gas that surrounded Jupiter after its formation. With a diameter of 4,820 kilometers or 3,100 miles, Callisto is roughly the size of Mercury. This moon has a thick crust of ice, 80 to 150 kilometers deep. It is made up of roughly equal parts rock and ice. However, it has one major difference from Ganymede. It does not undergo tidal heating and is therefore only partially differentiated. In other words, it does contain layers at different densities, but not at full depth. According to data collected by the Galileo probe, Callisto may have a small silicate core and an ocean of liquid water more than 100 kilometers beneath its surface. As on Ganymede and Europa, this ocean could harbor life. Its depth is estimated at between 50 and 300 kilometers, depending on the model, and its temperature would be around minus 20 degrees Celsius or minus 4 degrees Fahrenheit. Because of the high pressure, the water in this ocean would remain liquid. But beneath this ocean probably lies a layer of ice 300 kilometers or 185 miles thick, and a core composed of ice and rock. Callisto's surface is old, heavily cratered, and shows no sign of tectonic activity. Because Callisto is further from Jupiter than the other Galilean moons, its surface is less affected by the gas giant's magnetosphere. Callisto is surrounded by a thin atmosphere composed mainly of carbon dioxide and probably molecular oxygen, as well as by an intense ionosphere. Explored on numerous occasions by space probes such as Pioneer 10 and 11, Galileo and Cassini-Huygens, Callisto is often considered the most suitable body for a human base to explore the Jovian system. However, the likelihood of this satellite harboring any form of life is lower than for Europa or Ganymede. The impact of Jupiter's tides is not enough to properly deform the satellite, as Callisto is located too far from Jupiter. As a result, the satellite cannot draw much heat from the gas giant. What's more, Callisto is made up mainly of ice, whereas it would be preferable for water to be in contact with hard rock to be saturated with the elements necessary for the appearance of life. In fact, the low diversity of chemical compounds and low temperatures on this satellite considerably reduce the chances of life appearing and developing. But this possibility should not yet be totally ruled out. Unfortunately, no more is currently known about the possibility of extraterrestrial life on Jupiter's moons. These moons have been explored only briefly, by spacecraft en route to another destination. But more recently, projects dedicated to the study of Jupiter and its moons have emerged. NASA's Juno probe arrived in Jupiter's orbit in July 2016 and has since delivered extraordinary images of the gas giant. In July 2021, it moved on to study the Galilean moons. On September 29, 2022, it flew very close over the moon Europa, passing just 352 kilometers, or 220 miles from its surface. This was only the third time a probe had flown over this satellite. The flyby enabled the probe to take photos of the moon, as well as samples, to be compared with Galileo data collected at the beginning of the century. On October 16, 2023, images of Io were revealed by the American probe, which passed within 11,645 kilometers, or 7,500 miles of the moon. The European Space Agency's JUICE project is also eagerly awaited. Its aim is to study Jupiter and the 3 Galilean moons that could harbor life: Ganymede, Europa, and Callisto. JUICE stands for Jupiter Icy Moons Explorer. The probe was launched on April 14, 2023, and is scheduled to arrive in orbit around Jupiter in 2031, after a 7.5-year journey. This positioning will enable it to fly repeatedly over the Galilean moons to collect data. Researchers have high hopes for this project, because if all goes well, it could considerably enrich our knowledge of Jupiter and its satellites. In December 2034, the probe will orbit Ganymede to study this satellite in greater depth, before completing its mission in September 2035. Another mission is being developed by NASA, this time to study the moon Europa in depth. This is Europa Clipper. This automatic probe should leave Earth in October 2024 and reach the Jovian system in April 2030. These projects are promising and should help us learn more about the presence or otherwise of highly resistant living organisms in the subterranean oceans of these moons. Researchers don't expect to find little green men on these satellites, but rather simple organisms like those found on Earth, at the bottom of the oceans near areas of volcanic activity. But it's a good start, since life on Earth probably evolved from these ultra-resistant microorganisms. Could there be other moons in our solar system with conditions similar to Europa, Ganymede, or Callisto, suitable for the appearance and development of life? The Cassini-Huygens space mission was designed to answer this question. Its objective? To explore the Saturnian system, i.e., the planet Saturn and its satellites, determine how Saturn's rings were formed, and inspect some of the giant planet's moons. This mission, developed by NASA with the participation of the European Space Agency and the Italian Space Agency, was launched on October 15, 1997, and ended on September 15, 2017. After flying past Jupiter on December 30, 2000, the probe was placed in orbit around Saturn on July 1, 2004. On January 14, 2005, the Huygens lander detached from the probe and landed on the surface of Titan, Saturn's largest moon, while the Cassini orbiter continued to collect data on Saturn and its satellites as they passed close to the gas giant's orbit. The mission was scheduled to last 4 years but was extended twice, ending on September 15, 2017. The Cassini orbiter was equipped with the most sophisticated instruments ever taken to the outer solar system: cameras, spectrometers. Particularly costly, this mission was a real success, as it provided scientists with a wealth of data on the Saturnian system, Saturn, its magnetosphere, its rings, Titan, and the other satellites of this giant planet. Thanks to the Cassini-Huygens space mission, Saturn's rings have been revealed in detail for the first time. These rings stretch for thousands of kilometers, yet in some places they are no thicker than a few dozen meters. The Cassini probe has confirmed that these rings are made up of billions of shiny particles of almost pure water ice. These particles vary enormously in size, from a speck of dust to a mountain. The data collected has also made it possible to date the rings. They were created less than 100 million years ago and should disappear in less than 100 million years. But above all, the Cassini-Huygens mission has also enabled us to refine our knowledge of Titan and to discover astonishing features of Saturn's other moons, notably Enceladus and its geysers, clues to an underground ocean that could perhaps harbor a form of life. In all, Saturn has 146 satellites, 144 of them confirmed. It also has more than 150 helices in its rings, which could be minor moons, i.e., particularly small natural satellites. At least 150 minor moons have been detected in Saturn's rings through the disturbances they create in their environment. But researchers suspect that this is only a small portion of the total population of these objects. Saturn's satellites vary in size, from less than a kilometer in diameter to 5,149 kilometers or 3,200 miles in diameter for its largest satellite, Titan, which is larger than the planet Mercury. We'll now take a look at Saturn's two most notable satellites, Titan and Enceladus. Let's begin our journey into the heart of the Saturnian system by exploring Titan, the largest of Saturn's moons. Titan, or Saturn VI, is the second largest moon in the solar system after Ganymede. It was the first moon of Saturn to be discovered, by Dutch astronomer Christian Huygens in 1655. One of Titan's special features is that it is the only known satellite to have a dense atmosphere. Its atmosphere is made up of 98.4% dinitrogen and 1.6% methane and ethane, and lies between 200 and 880 kilometers in altitude, i.e., almost 500 miles above sea level. To give you a point of comparison, on Earth, 99.99% of the mass of the atmosphere is less than 100 kilometers or 60 miles above sea level. It's also difficult to obtain a spectrum of Titan's surface, as its atmosphere is opaque over a wide range of wavelengths. Titan's atmosphere contains layers of opaque fog that block out most of the sun's light, so much so that the Huygens probe team described the process of photographing Titan's surface as photographing an asphalt-covered parking lot at dusk. The temperature of the atmosphere is around minus 180 degrees Celsius, or minus 292 degrees Fahrenheit, and reaches minus 200 degrees Celsius, or minus 328 degrees Fahrenheit, at the tropopause, at an altitude of 40 kilometers, or 25 miles. According to observations by the Voyager probes, the pressure at the satellite's surface exceeds 1.5 times that of the Earth. Titan is composed mainly of rock and frozen water. Its surface is geologically young, with a few mountains and cryovolcanoes, but overall, a relatively flat and smooth surface, with few impact craters. Winds and methane rains, which are frequent on Titan, create dunes and coastlines on the satellite's surface, just like on Earth. Titan also has seasons. When Cassini's Huygens module visited Titan in 2004, it detected elements of life in its atmosphere. But that's not all. As it flew over the moon, it detected something mysterious, partly hidden by the clouds gathering over its south pole, resembling a lake of water. Numerous flybys subsequently revealed the existence of hundreds of such lakes, scattered across the moon's north and south poles. What is the significance of these mysterious lakes? Could it be that, as on Earth, they are lakes of water with a rich ecosystem? This question has intrigued researchers, as Titan is the only known environment other than Earth to feature liquid expanses on its surface. But given Titan's surface temperature of minus 180 degrees Celsius or minus 290 degrees Fahrenheit on average, these lakes cannot be lakes of liquid water. After analyzing the infrared waves reflected by the lakes, the researchers concluded that they were in fact liquid methane and ethane, at very low temperatures. On Earth, these elements are used as fuel in gaseous form. But on Titan, liquid methane digs valleys, forms clouds, and falls as rain. In fact, it behaves exactly like water on Earth. Researchers then wondered whether this methane could be conducive to the formation of life, allowing organic molecules to dissolve, mix, and interact, just like water on Earth. Our theory of life includes the need for a liquid element. On Earth, water enables organic molecules, the basic ingredients of life, to dissolve, assemble, and interact with each other to form larger, more complex molecules, destined to develop into living beings. But could another liquid do the trick? could the building blocks of life dissolve in methane and give rise to life? Astrobiologist Chris McKay has attempted to answer this question. To do so, he used the elements detected in Titan's atmosphere by the Cassini mission and carried out a simulation. First, he reproduced the reaction that takes place on Titan to obtain the same organic material as in its atmosphere. Next, he recreated the lakes detected by the Huygens module's radars by filling a test tube with methane gas, which he cooled to minus 143 degrees Celsius or minus 225 degrees Fahrenheit using liquid nitrogen. The methane liquefied exactly as it does on Titan's icy surface. Chris McKay was thus able to obtain a miniature Titan lake in his test tube, namely, a bath of liquid methane with organic materials. The aim now is to find out whether these materials will dissolve to form more complex molecules and ultimately a new form of life. If these organic materials can dissolve, it means that the chemical processes necessary for life could exist on Titan, and on a larger scale, that they are capable of being triggered even in conditions of extreme cold and in liquids other than water. This would also mean that life has arisen twice under different conditions, and that it is therefore a natural process that can appear in other places. This would open up infinite possibilities. In any case, if there is life on Titan, it bears no resemblance to life on Earth. While we await the results of Chris McKay's experiment, other evidence of possible life on Saturn's satellite has been put forward. A team of researchers has identified a deficit of acetylene on Titan's surface. This molecule, which forms on the planet's surface, should be present in Titan's lakes, but has not yet been detected. According to Chris McKay, acetylene could indeed be the food of choice for hypothetical life based on liquid methane, but nothing is certain yet. The lack of acetylene could just as easily result from the action of sunlight or cosmic rays, which are capable of transforming acetylene into other, more complex molecules that no longer display its spectral signature. Whatever the case, researchers are still hopeful of finding some form of life on Titan. This moon of Saturn closely resembles a primitive Earth, albeit at a lower temperature in many respects. Its liquids on and below the surface, its thick atmosphere of diazote, Titan could well contain extraterrestrial microbial life, or at least a prebiotic natural environment rich in complex organic chemistry. Another of Saturn's moons has attracted the curiosity of researchers, Enceladus. On the face of it, this satellite isn't the most interesting. It's only Saturn's 6th in size and 14th in distance. But since the Voyager 2 and Cassini-Huygens missions, researchers have been taking a close interest in this small moon, which boasts some astonishing features. Enceladus is a real mystery, very different from Saturn's other moons in its appearance and shimmering white surface. It displays a complex geological activity, difficult to explain for such a small body. Indeed, Enceladus measures only 500 kilometers or 310 miles in diameter on average. However, the Cassini probe has spotted cracks, protrusions, and fissures on its surface, showing that there has indeed been activity on this moon. In fact, one of the objectives of the Cassini-Huygens mission was to find out whether this geological activity was still taking place today. Take a close look at these images taken by the Cassini probe. You can see 4 strange blue faults running parallel down towards the South Pole. These faults have been nicknamed the Tiger Stripes. 120 kilometers, or 75 miles long, they are several hundred meters deep and bear disturbing similarities to earthly faults. The probe's thermal sensors recorded some surprising data at Enceladus's South Pole. While these faults should be colder than the rest of the Moon, they radiate heat. In fact, the faults are on average 95 degrees Celsius or 200 degrees Fahrenheit hotter than the rest of the Moon. The mystery surrounding Enceladus thickened when the probe changed its perspective. As Enceladus passes in front of the Sun, immense geysers can be seen, erupting from the Tiger Stripes. These immense jets of matter rise up to hundreds of kilometers. So, does Enceladus harbor an energy source like Io or Europa that could explain these geysers? The answer is yes. Like the 2 Galilean moons, friction generated by gravitational forces causes the Moon to heat up and melt ice. As it approaches Saturn, the Moon Enceladus undergoes a torsion that creates internal heating, exactly what happens when a piece of metal is bent. The jets observed by the Cassini probe are in fact liquid water vaporized in space, freezing on contact with its icy temperature. These jets are propelled at an impressive speed of nearly 200 kilometers per hour or 125 miles per hour. So there could be liquid water beneath the surface of Enceladus. The Cassini-Huygens space mission team programmed the probe to pass through these jets in order to sample particles and better understand their origin. After several passes, the probe detected some of the elements that make up living organisms. The discovery confirmed that yes, there could be life on Enceladus. The Moon contains 3 elements needed to be considered potentially habitable: liquid water, a powerful heat source, and organic material. What would life be like on Enceladus? Around the Tiger Stripes, we'd be in a region of eternal snow, since it's been snowing on Enceladus for at least 100 million years. The sky would be black, and we'd have the impression of floating due to the low gravity. We wouldn't be able to see anything with the sun at our backs, but facing the sun, we'd be able to see the immense geysers cut through the light and fall to the ground in a thick white mantle. For the moment, there is no evidence that Enceladus harbors life. Cassini's instruments have not detected any trace of life as such. But Enceladus is definitely on the list of next destinations to visit during space exploration missions. What's more, to analyze the Moon's underground water content, you don't have to dig as you do on Europa. Just walk through the geysers. All the particles are sent into space, ready to be collected and analyzed. Apart from the Saturnian and Jovian systems, are there any other moons in our solar system that could potentially be habitable? Of the 214 moons identified by NASA, there must be more. To answer this question, scientists have turned to Uranus, Neptune, and Mars. Uranus and Neptune were overflown in the 1980s by the Voyager 2 probe. Scientists held out little hope of the habitability of these icy planets, which could not harbor liquid water, but after the discovery of oceans in unlikely places, the data collected on these planets and their satellites was revised. Uranus has 27 moons, but only 5 have been analyzed in depth: Titania, Oberon, Umbriel, Ariel, and Miranda. If an internal ocean existed on Miranda, the smallest of the satellites studied, it would probably have frozen over by now. But it's entirely possible that the other 4 moons contain an internal ocean. Depending on the moon, scientists have developed different scenarios to explain the origin of an energy source. On Titania and Oberon, the 2 largest satellites, heating is thought to be due to the tidal effect of Uranus, while on Ariel, it could be explained by cryovolcanic activity. The scientists' conclusion is that there may be internal oceans on the Uranian satellites, but they are relics of former oceans, or residual oceans, rather than thick oceans. And what about Neptune? The 8th planet from the Sun, Neptune, like Uranus, is what we call an icy planet. Of its 14 satellites, the one that most interests researchers is Triton, its largest, with a diameter of just over 2,700 kilometers, or 1,700 miles. Triton is an astonishing moon. It's the only known large satellite in the solar system to orbit in the retrograde direction, i.e., in the opposite direction to the planet's direction of rotation. For this reason, Triton may be a Kuiper Belt object captured by Neptune. It is also the only moon, along with Phobos, one of Mars' 2 moons, to approach the object around which it orbits. Our moon, on the other hand, is moving away from the Earth by about 3.8 centimeters, or 1.5 inches per year. While flying over Triton, Voyager 2 observed geysers 8 kilometers, or 5 miles high, over 180 kilometers, or 60 miles, all concentrated in the region of Triton, currently facing the Sun. These geysers would therefore have a solar origin. Researchers believe that Triton harbors fairly recent cryovolcanic activity, which explains the nature of the terrain observed by the Voyager 2 probe on its surface. Like Europa, Ganymede, Titan, and Enceladus, Triton could be home to an underground liquid ocean. To find out more, a mission project had been developed, the Trident mission, but it was not selected to be part of NASA's Discovery program. Instead, missions to Venus were chosen. No doubt another mission will be developed to answer the many questions scientists have about this mysterious moon. Where do its geysers come from? Why is its landscape constantly changing? Why does it have an intense ionosphere? Let's end our exploration of the mysterious moons of our solar system by getting a little closer to Earth. We're on our way to Mars and its 2 moons, Phobos and Deimos. These 2 moons share many characteristics with C-type asteroids, primitive bodies dating back to the genesis of the solar system. But contrary to what researchers have long believed, these are not primitive celestial bodies that were attracted to Mars from the asteroid belt like Triton. Not only is Mars' gravitational pull too weak, but their orbits are too circular. Phobos and Deimos are more likely to be the result of a collision between Mars and a giant celestial body. Perhaps these 2 moons were born at the same time, but their trajectories are different. Phobos is approaching Mars by around 2 meters every 100 years, while Deimos is moving away. In fact, Phobos is the closest satellite to its planet in the entire solar system. Its surface is dotted with craters, fissures, and other marks left by meteorite impacts. According to the researchers, Phobos will be destroyed in 30 to 50 million years due to deformations caused by Mars's tides and gravity, while Deimos will probably move away and emancipate itself from Mars' gravitational pull. In any case, these two moons are unlikely to harbor life. In the quest for extraterrestrial life, it's Mars that interests researchers. Europa, Ganymede, Callisto, Titan, Enceladus, Triton. All these moons could be inhabited by forms of life we can't yet imagine. Research carried out in recent years on the moons of our solar system has shown us that there are worlds not so far away from us that are very different from our own, and yet could be home to extraterrestrial life forms. But is life on these seemingly cold and hostile moons possible? On Earth, we've discovered that life can cope with far more extreme conditions than previously imagined. Some microbes can live in arid deserts, in lakes saturated with arsenic, or on the walls of caves dripping with sulfuric acid. Environments that are toxic for us can be conducive to the development of other types of living beings, ultra-resistant organisms, unsuspected forms of life. Everywhere on Earth, life manages to thrive. So why not in underground oceans, sandwiched between several layers of ice and maintained in a liquid state by an internal energy source? Recent discoveries have prompted researchers to rethink their models and re-examine what they already know. Worlds that had previously been considered too hostile are now being re-examined and analyzed from a different angle. Whereas before, the search was for Earth-like planets, the field of possibilities has been broadened by looking at other types of celestial bodies, which offer other conditions and environments, and which may favor different types of chemical processes, with a result that could well be life.